Again, my name is Jesse, and in this session of the tutorial, we're trying to learn about Python. So what is Python? So Python is a very powerful programming language which is very easy to learn, but it's very powerful. It can be used to do a lot of things, right? So learning Python is never going to be a waste because you can use it to do several other aspects. So before we start learning about Python, let's learn what programming is, right? So what is programming? So I've written a simple tutorial on programming and then the types of programming on our blog, right? JCharisTech blog. So you can just read about it in case you want to know. But simply, a programming language are just programs, or they are just tools used to communicate with and between computers and human beings, right? So you can just see them as tools used to communicate between programs and human beings to be able to solve a problem or to perform a task. That is the basic understanding about it. So in order for humans to be able to communicate with computers, they have to use programs, right? Programming language. So that is the basic idea. So every programming language has its own syntax, but they mostly follow the same principles and the same grammar, right? But they may have different syntax, just like normal languages may have the same grammar, like almost the same principles, but different syntaxes, right? That's the same understanding about programming language. So there are 100 different kinds of programming language, as we learned earlier on, from A to Z. So as a matter of fact, if you go to Wikipedia, right, list of programming languages, you can get a programming language starting from A, or the alphabet, you can get all of them. One from A, which is A++, right? Very interesting. A plus or A++, A plus, and A sharp, even to Z, right? Z++, right? Very interesting. So there are several programming languages, but the best is to pick a particular programming language and then learn from it. So we are picking Python for now. So that is a big idea. So to start with Python, just go to python.org. Then you can just go to the downloads option. Then you download the particular one. So if I go to the downloads here, I can see that you have Windows. So in case you are on Windows, you can get it for Windows, for Macintosh, for Linux, right? Then just click on it. So click on Windows, go to open, then you just click on it, then you install it perfectly, right? So that is the basic idea about installation, which is very simple. In case you don't want to install it on your system, there are several places you can also use it. So you can just go to your browser, right? Your browser, and just go to repo.it, right? /languages/python3, right? Don't forget repo.it. So with it, you can run Python in your browser, right? That is, you must have internet. That is another way of using it. That is one way of using it in case you don't want to install it on your system, but it's recommended that you install it on your system. It's very simple. And then in this tutorial, there are several things you'll be using. First of all, we will need a text editor to write our code, right? So we can use Sublime Text. You can also use Visual Studio Code, right? It's a very nice one here, which you can install and use to run your program. Very interesting. So these are the two most commonest one. Of course, there are several ones you can use. Then the next option is to use a very simple tool called Jupyter Notebook, right, or Jupyter Lab, which makes it easy for you to run not only just Python but several other programming languages such as Julia, Python, and R, which you'll be learning in the coming future, right? So that is another tool we'll be using in this tutorial. Then in case you don't want to use any of them, as I said, you can use REPL, right? In case you don't want to install anything, just use REPL. Or you can go to your Gmail account, then go to Colab, right? So if I go to Colab, you can also run the same thing there. So Colab is just like Jupyter Notebook, something very simple, right? There is something very basic about it. So these are just introductory stuff. So this is how Colab looks like, just like Jupyter Notebook. So let's start working with it. So give some time for it to run. That is why it is slow, right? So this is how Colab looks like. Very interesting. So let's start with it. So first of all, there's also another place you can search for every Python point, right? So you just go to pypy.org. So these are the basic understanding about Python. Python was created by a certain man, and his name is called, let me search it out. So Python wiki, in case you want to learn more about what Python is, not the animal but the programming language. So this is it. So let's check it out. So very simple programming languages with a lot of benefit, right? You never regret learning Python. So this is something about it. And the creator was called Guven von Rosen, right? It It was first released in 1991. That is, Python is almost about 19 years old, very old. So this is the guy that invented or created the programming language called Python. Very interesting. So that is a brief history about Python. Now let's start with actual code. So after you have finished installing it, you can just go to PyPy here, right? If you go to PyPy, just search for Jupyter Lab, right? If you search for Jupyter Lab inside PyPy, you can be able to see the program and see how to install it. So this is it, right? So Jupyter Lab. Then in case you want to install it, you just go with pip. The information is here. How to install it will be shown in a pip install. So you can just copy this one here, right? You copy it, then you go to your terminal. In this case, I'm using Linux. Then you paste it here, right? That is how to install Jupyter Lab. But I've already installed it, so we can just move straight away to it. In case you're on Windows, you do the same thing. Now let's start working with it. So I'll just go back to my location. So let's start with it. So let's start. So to run Jupyter on your system, this is not recommended, but in case you want to use Jupyter Notebook, you can just go with Jupyter Lab, right? Then it's going to open Jupyter Notebook, in which you can use to do your stuff. But in case you don't want to do this long stuff, you can just go to your browser, which is taking some time. My system is getting slow. Then you just go to repo.it, right? Repo.it. Then you can do the same thing that I'm doing, right? Or you can just go to Google Play Store, then download Python for your app, for your phone, so that you can also try it out. Or can use Colab, right? These are the several ways you can use it. So at least you have no excuse. So when I run Jupyter Lab, it's going to open the Jupyter Lab for us. So this is it, and then we can see how to work with it, right? So it's automatically going to open your browser, or you can just copy this one and paste this URL. So I'll copy this and paste it inside my browser, right? Any browser that I want. So it's becoming slow, so I may take off some of them. I may take off the video so that at least we have some speed for what we are doing. So I'll just copy it from here, then I'll paste it inside the browser, right? So it's automatically going to open my browser, which is going to be my default browser, which is Mozilla, but I'll be using Chrome because Chrome is better and Chrome is cool, right? So to see that it's open my default browser, right? That's how it's going to be, but let's use Chrome, right? So I'll close it and then I'll paste what I copied inside Chrome. My system is slow. Apologies for that. So I'll paste it inside my Chrome browser, right? Something very simple. So all these things we are doing is just an introduction to it, so that in case you don't have it, you can try it out. Alright, so everything has been set up. So the Jupyter Notebook has been opened. So let's start with it, right? But before we start, one thing is that anytime you learn programming, you can be able to use it in all of these particular fields. So these are the 7 domains of programming: design, development, database, DevOps, data science, defense, digital marketing, right? And then you can earn money in any of these fields. You can become any of these fields, right? So this is the advantage of learning Python. With Python, you can do any of these things. Now let's start with it. So this is going to be the basic outflow of what we'll be doing. We'll be learning about the basics of Python. That's the level 1, 0.1. Then you have the level 0.2 to 0.3, which is going to be for the future. So for now, this is going to be our outflow. Learn about data types, variables, numbers, strings, arrays, functions, models, dictionaries, tuples, sets, conditionals, and then loops, right? And then file, input and output. That's going to be for level 0.1. Then in level 0.2 to 0.3, learn about data structures and collections, object-oriented programming, decorators, generators, which is going to be for the future, right? So let's start with it. So level 0.1, that is Python the basis. So what is a variable, right? What is a variable? So a variable are usually words that are used to store values or data, right? That is the basic definition of a variable. And then usually it is used to reserve a location in memory to store your value, right? That is something very basic about it. Then in Python, to create a variable, right, you just put a name, any name, then you assign it to a value. So let's try it out. So it's going to be something like this. So very interesting. So to create a variable, just any name. So let's go as a name. Now pass in or assign a value to it. So this is not an equal to in Python. This is an assignment, right? Although it's equal to, but it is assignment. So I'm assigning a value to this. So I can say that this is hello, as everybody does hello world, but you say hello Python, right? So I am telling Python, right, the interpreter, that store this word hello Python, right, into this name called name, right? So this thing is now a variable. That is a basic idea, right? So if I run it like this, it's now going to pick a space in the program and then attach this particular stuff there, name, and then store inside that particular name hello Python, right? Very interesting. So I can also store other stuff, not just name. I can also store things like, let's say, number. So it can be any number, right? And it's also going to store that particular number there. Something very basic. I can also store not only this number, I can also store several other stuff. So I can say, let's say this is going to be my list. I can also store several numbers. So let's say I want to store not just, let's say, put inside this bracket and store some things there, right? So this is also a variable, right? So variable is a name that stores a value or data. Very interesting, very nice, right? So the type of data it is storing is what is termed as data type. So there are several data types there. So they refer to the type of value or variable a variable has, right? So the type of value, this is a string, this is a number, this is a number and a list. So these things are termed as data types. That is something very simple. So there are several common data types. We have a list, we have a dictionary, we have a string, we have tuples, we have numbers, we have set, and several of them. So to check for the data type, you just go with type, then you pass it inside. So let's try that one. So we have this one as a string, right? So in case I want to check for the data type of this, I'll just come back to this place and go with type, and I'll pass in name, right? If I go with name, it's going to name referring to this particular variable. We determine that this is a string. So that is one data type. That is a type of data that this variable is holding, right? Very interesting. The same way, if I check for the type of this, just go with type, and then let's pass it here. So there's going to be type, right? Now passing the name, which is num. If I pass in num, it's going to tell me that it is a number, right? It's an integer, right? Very interesting. So this is a data type, and this is a variable that is storing that particular value of the data type integer. The same thing with this. If I do the same thing for this one also, which is a list, it's going to tell me that this is also a list, right? So type, then I'll go with this option of my list. It's going to tell me that this is also a list, right? Very interesting. So that is the basic understanding about a variable and then the value that they store. So the value that they store can have several types, right? As we have understood. Now, in case I want to show what I have entered, right, the name, there are several ways. So the simplest way, just go with print, then I'll supply in the name. So I go with print name, I'm going to print the value that was stored inside that particular variable called name, right? So that is how to output or show the value of a variable. So in the same way, I can also try something like this. Print, say hello world. It's also going to print it perfectly for us. See how I spelled the word wrong spelling. Apologies for that. Right, it's also going to print it out perfectly for us. So with the print, you can be able to output or show the value or any other stuff, right? Very interesting. It is something nice about it. Now you have seen how to check for the type of something. So if I go with type, to check for the type of something, I just go with type, and I'll pass in the particular type. So if I go with name here, it's going to tell me that that was a string, as we learned previously. Very interesting. So as you have so far, what you have learned is that variables can store different data types. So it can store a list, it can store a string, it can store an integer or a number, then other stuff, then etc. So variables can store different data types, as you have learned so far. Very nice and very interesting. So let's move on to the next session. So this is everything from scratch, so to be more detailed and then with a lot of notes taken, right? Very interesting. So let's see other stuff we can also do. So variables can also be a boolean, not just a string or a list or an integer. It can also be a boolean. So for example, let's say this one can also be a boolean. So example is t. So if I go with t, which is standing for true, right? This true is a boolean, right? So a variable can also be a boolean, right? So if I check for the type of this, so let's check for the type, as we learned earlier on. To check for the type, just go with type, then I'll supply the particular stuff, which is t, right? The variable. So the type of this is bool, right? Boolean, right? So variables can also be a boolean. Very interesting. So this true is a reserved Python word, keyword. So there are some Python keywords which are already reserved, right? One of them is true. Very interesting. Now let's see what is behind the scene. As you learned earlier on, that Python is a high-level programming language. It's a tool that is used to communicate between the human being and then the computer. So how does the computer see it? So we can try an example of that, right, behind the scene. So let's try an example. So I'm just going to create a variable with something like, let's call this one as simple variable. So let's call this example, right? Then I'll pass in a simple name like hello world or hello Python. Everybody has been in the hello world. Let's use hello Python. Something very simple. So this is a variable storing the string hello Python, right? In case I want to see what is behind the scene, there's a very powerful package called this, right? So to help you to see what is behind the scene. So I just go with import. Import is a way in which you can import a particular package or a model. So import this. We'll be learning about that later. Then if I go with this dot this, I can pass in my variable of x, right? So this particular variable is going to analyze it behind the scene and give us what it is, right? So I made a mistake somewhere, right? So let's fix it out. Let's make it like this. Let's run it again. So if I come back again, we'll be making mistakes, of course. And let's run it again. And it's going to tell us in a very simple way, right? Very, very nice. So inside this example, hello, what is behind the scene, what the computer is going to see, right, is that it's going to see this load name, right? This is converted into assembly, load name, and then a return value, right? So this is the name there, 0, which is hello, right? Very, very interesting, very nice. So that is something behind the scene of every variable that you are creating. So it's going to reserve a space inside memory and store these particular stuff. It's going to load a name, and that name, what is there, is that it's going to have this particular stuff called hello there, right? Very interesting. Now let's learn about numbers, right? So what are numbers? So before we move on to numbers, there are also other stuff you can do. You can also create a variable in different ways, not just a simple way. So you can create a variable in multiples, right? If I want to create variables in multiples, I can do something like this, say A and then B, right? And then C, right? So I can group them A, B, C. Then I'll assign the particular value there. So let's say 3, 2, 4, let's say 6, right? So it's automatically going to assign A to 2, B to 4, C to 6, right? Very interesting. So that's another way we can also create variables. So if I go with A, print A, it's also going to bring A for us, right? 2. Very interesting. It will automatically know that A stands for 2, B stands for 4, C stands for 6, right? So if I go with C, it's also going to bring 6 for us. Perfect. So that is the basic idea behind variables. Now let's move on to the next data type called numbers, right? So numbers is just like numbers. So with numbers, you can actually, with Python, you can actually use your Python interpreter as a calculator, right? In case you are given an assignment, you can also use your Python interpreter as a calculator because it can work with numbers. So we have operators. So as we know, this is s plus y, right? So this s and then y are the operands, right? And then this plus is the operator, as we already know. So Python support all the various mathematical operators and then all the various mathematical notations. So let's for arithmetic and for math. So let's see how to work with this. So there are some extra packages in case you want to do more. You can start with math package or statistics or Numpy, right? So let's see some basic stuff we can do with it. You can do simple addition, it will work. Simple subtraction, division, multiplication, modulus, right? Finding the number and the remainder, exponential, and then floor division, which is going to remove the last digit right after the point, right after the decimal point. So I don't know whether you can see it very well, but let's run it and see. I'm going to run it perfectly for us, right? So that is how to work with numbers, right? So you can do all the basic math activity, bed math, right, or board math or paired math, as you wish. Python also have some assignment operators. So we have seen these ones that we have done, right? So these are also assignment operators. So we have this equal to, less than, not equal to, which is also the same thing, then greater than, less than, greater or equal to, and then less than or equal to, right? So you can do all the various mathematical notations with Python. We also have some logical operators, which is very interesting. So we have the and or, which means that take s, right? This plus is equal to, or is also called and, add, right? Add and, the same as x is equal to s plus 1. So let's try an example. So there are also, these are the various logical operators, right? So it will be around so that you can actually look at it. So we have subtract n, multiply n, divide n, exponent n. And the basic idea is that you're just going to take that number is equal to that number plus 1, right? Or minus 1, like that. That's the basic idea. So instead of you writing this long way, you can also do it this way, right? That is something interesting. Okay, very nice. So let's see or learn about membership operators. So membership operators that can be in and not in. So Python is just like English, right? Very, very interesting. You can check whether a particular term is found inside a list or not. Then you also have identity operators, which is usually used to compare the memory locations of two objects. So let's see an example. So this is how to do that, right? Something very simple. Let's see an example of the in and then the is. So let's say I have something very simple. I'm going to have some numbers. So let's call it as my numbers. And I'll store inside this two numbers. So let's say, right, I have this. So in case I want to check if these numbers are there, I can also do something like this. So let's say 24 in that particular number, right, inside my numbers. So this thing I've done here is how to create a list, right? It's true, right? 23 in numbers is true. So we can use the in as we learned here to check whether it's there, and you can also use the not in. So I can also do something like, let's say 5 4 not in, right? And it's also going to work in our number, and it's also going to work. So it's going to tell us that's true, right? So you can use the in and then not in, which is very interesting, just like English, right? So this is how to create a list, which we'll be learning on in the future. Now let's learn about strings. So what are strings? So strings are a set of characters, right, which are represented in quotation marks, right? It's a format of a sequence, but it contains only characters. And usually in Python we use single quotes, double quotes, or triple quotes. So let's try an example. So there are several interesting packages that you can use to help you do more with strings. We have the strings package, Unicode, FTF fits this for you, and then several NLP packages. So let's try and see how to create a simple string. So I'm going to create a string called first name, right? First name. So that's a variable name, right? Then I can put in a string. So the string can be inside a single quote like this, or double quotes, or triple quotes, right? As you wish. But it must be inside the quote, otherwise it's not a string. So if I go with this, so I can just say that my first name is Jesse, right? So this is going to be a way of creating a string. So this thing here is a string. So if I run it and I want to check for the type of it, just as we did it earlier on, So type, then I'll pass in my first name. Going to tell me that this particular stuff is a string, right? The data type is a string. That is how to create a string. That is the first method of creating a string. And there are several stuff you can do with string. That's the first method of creating a string, right? Using this particular option. So let's go back and try something else. It's freezing. Anyway, we are doing everything from scratch, so no editing. Now, perfect. So that is how to create a string. So this is a string in single quote. I can also make it in double quote. So let's call it as, let's say, paragraph, or let's call it as message, like MSG. Then I can put this one inside triple quotes, right? Which is also going to work. So let's say this is a Python programming tutorial, right? And I can even come down and then add more text to it. So where we learn all the basics in one video. So I made a lot of mistakes, but let's move on. So that is so with the triple quote, you can put in different levels, right? Different levels. And if I run it, I'm going to store this particular stuff inside this particular variable. Then if I check for the type of this, it's still going to tell me that this is a string, right? Very interesting. So there are several things you can do with strings. So yeah, a lot of things you can do with this. So let's try them out. So in trying to manipulate a string, to see everything that a particular object has, just go with the dir directory, right? So let's try that one. So I'm just going to go with my dir for the first name. I'm going to list all the various attributes and various methods that I can do with this particular string. So I can add, I can check if it contains a particular stuff, check for the directory, which is what you have done now. I can check for the docs if there's having a documentation. I can do some formatting, all of these particular methods, right? I can check for the size of it. I can also capitalize. I can check the center, count it, encode it, check whether it ends with. So these are all the various things I can do to my string, right? Very, very powerful, right? So I can do all of these things out of the box because Python, everything in Python is an object, right? So this is being seen as an object. So it gives out to convert our first name to capital, right? So I can just do the same thing. So let's go just print, say upper case, right? I'm converting it to uppercase of our string, so I can just do something like that. So let's try that one out. So it's going to be my first name, right? Then I just go with dot upper. So the dot upper is what we saw here. See that we had lower here, right? We also have upper here, right? So you can just use any of these things to convert and manipulate your string. I don't know whether you can see it, or let's change it. So to change it, go to settings, come to theme, then I'll change it to light so that at least you'll be able to see what I'm typing for now, right? We may change it back to the black because the black is cool to help our eyes. Take some time for it to change to the white theme. Perfect. Okay, I think you can see it better, right? Okay. Somebody's saying, why didn't I start using white? Anyway, black is better for me, for my eyes. Okay, so that is something very interesting, right? So with the dot upper, as we saw here, we can convert this entire stuff, the first name, right, into uppercase. See what I spelled very wrong. Right, so let's correct it. So this first name. So in case I want to convert the first name to upper, I just click on it. We're going to convert it to uppercase for us, right? Very interesting. So that is the power of strings. So I've converted this one to uppercase in a very nice format. I can also do it for several of them. So let's try them out. So I'll copy this one here, and let's see the various manipulations we can do to our string, right? So I'll convert it to uppercase. So let's copy this one here and then duplicate it. So copy this one. Let's try it again. So I can convert it to lowercase. Do most of them so that you see how to work with it. So this is for uppercase, right? So let's make it like this. Then I'll go with lowercase, right? This is going to help us to convert it to lowercase. In case I also want to get it as, let's say, title case, as you know, like title. I can also go with title. So let's spell it well. Title, right? Then in case I also want to get it as, let's say, capital, right? Can't spell, capitalize, right? So this is going to be capitalized case. There's nothing like capitalized case. Just capitalize. I don't know, I'm spelling capitalize. Okay. Right, capitalize. Then the last one is going to be for, let's say, swap case, in case I want to swap it. So it's going to be swap case. So with Python you can do a lot of things. You can do a lot. It's going to be our swap case to swap it, right? So this is going to be swap case. Very interesting. So let's see the result of what you have done so far. Hopefully it doesn't give us any error. Perfect. So you see that the uppercase is, everything is going to be in uppercase. Everything is going to be converted to lowercase. Title, you see that the first letter is title, capitalized almost the same, and then the swap case is also swapping it, right? So the capital, so the first one, which was capital, will be converted to lower, the remaining will be upper. So let's try another example so that you see it very well for the swap case, right? So that's something like this. So we can just create something very simple. So let's make it like this. So hello, right? The hello is small letter, then world is capital, right? So in case I want to swap it, right, I just give it dots, because this is also a string. Dots, right? Swap case. They're going to convert this entire stuff into, this is going to be uppercase, and this is going to be lowercase. That is the power or the difference between, right? So that you can see it very well. So I just converted them. So swap case is going to turn it the other way around. Now in case you want to find the length of a string, let's say I have my first name string, I want to find the length, just go with length, then my first name. Remember, this first name is referring to the variable, right? Not the word itself. So this is referring to the variable what is stored there, as we learned earlier on. So this is going to give us 5, right? That is how to find the length of a string. There's also something called string indexing. So in case I want to get the particular index of something, so let's change it from first name, because first name looks too long, f name, then let's call it as Gudo, right? Gudo, one of the greatest, Gudo 1, something like that. So in case, right, Gudo 1, and I want to, it's not the first name anyway. In case I want to start from indexes, start from 0 to 1, right? I can also do the same thing. So f name, then I start from, Python start from 0. We don't count from 1, we start from 0, so 0 to, let's say, 1. So we're going to print only the first variable there, which is g, right? So 0 to 1. In case I also want to get from 0 to, let's say, another variable, let's say 4, right? I can also do the same thing, right? Very interesting. So good. So it's able to use this option of indexing or slicing, right? Not splicing, slicing, to be able to get the particular value there, right? Very interesting. So as we learn, to get the length of this, you can also do the same thing as we did, which can be the length of the f name. How to print it perfectly for us, right? See what I wrote. I'm making a lot of mistakes. I'm not going to edit it anyway. So this is going to be 9. So from 0 to 4, I was able to get it. In case I want to get from 0 to the end, I also do the same thing, right? So it's going to be f name, then 0 till 9. So this is 9, but it's going to be 8 because Python counts from 1 to 9. So it's going to print everything perfectly, right? So this is, that's giving us 8. So in case I want to reach that particular value, just go with 9. Go to print everything perfectly for us, the full stuff. Very interesting. Nice. So what if I want to print everything without if I don't know the count, the length of my string, and I want to count everything? How do I do that? So in that case, I just go with f name, right? And I just go with 0 with the colon. So it's going to automatically go to the end of it. Perfect, right? So even if it is 10,000, it will still go to the end. In the other way you can also do this thing is that in case I also want to get the last value. So let's try that one. In case I want to get the last value. So this is from beginning to end. So in case I want to do from the end. So in that case it's going to be like this. So f name. Right, now go with this option. So this -1, right? So if I go with -1, it's going to start counting from the back -1. That is the basic idea. That's counting from the back -1. No, this is not the best way. It's supposed to be this. It's going to omit the last one, right? But in case I want to get from the end, -1, right? Slash. So if I go with the column, it's going to pick the last value, which is n, right, for us. Very interesting. So that's giving us n. The same in case I want to get to 2, just do the same thing. Go to count to the second one, which is a, right? Very simple and very nice. So an. So I've gotten an. So in this same option, can actually use to reverse a particular string. So let's try and see how to reverse a string. So to reverse a string, there are several ways. The simplest method is just go with fnam using the indexing. Then I'll reverse it by going with this option of right -1. So this option is going to be used to reverse our string for us. Hopefully it doesn't give us an error. That has reversed it perfectly for us. So that is how to reverse a string in Python. I think you can also use the verb reverse. So the function reverse to also do that. So f name, right? In Julia this will work perfectly, right? But in Python it's not working, right? There's no function for that. So this is the best option. Okay, so now let's move on to how to find characters in a string. So how do you find a character in a string? So to find a character in a string, we already learned about the count, right? So to find a character or position of a character, as we learned that a string is a collection or a set of characters. So in case I want to find the position of a character, let's see how to work on it. So we learned that, let's take something like this. So we learned that fname had 9 characters, right? It had 9. So in case I want to find the position of this particular stuff, and also do the same thing here by going it like I want to find the position of a character, right? Which was, let's bring it out so that at least we see what we are doing. So it's going to be my fname. So I can print it out, right? Print fname. So Gudon Von is the name that we are printing, right? So in case I want to pick, let's say I want to pick I, right? I want to find the position of I, which is 0, 1, 2. So I can use the find option to help us with that. So in that case, it's going to be my fname dot find. Now pass in the particular character that I want, which is I, right? I'll pass in the I, the string or the character I. Going to tell me that it is found in number 0, 1, 2, right? Very interesting. So that is how to find the position of a character using the dot find, right? It's going to find a particular position. So 0, 1, 2. Very interesting. Now, in case I want to get the number of or the count of a particular variable, right? So let's say I have a word like remember. You know, remember is one of the most difficult words to spell. Remember, because we don't remember how to spell remember. Remember, because I want to find the number of a particular character, right? So we have 3 E's, the E, or 2 M's and 3 R's. Because I want to find the number of counts of a particular character, I can just go with count. I've applied a particular character. So let's say I want to search for the number of M there. So we have 2M. It's going to print it out perfectly for us. So that is 2. Very interesting. The same way, in case I also want to try out for, let's say, a different character like E, which is 3, I'm going to count the number of 3 there for us. The number of E, not 3, which is 3 in this case. So if I go with E, it's going to print it out perfectly for us, right? The number of characters, the number of counts of that particular character, E, 3. So we have 1, 2, 3. That is how to count the number of a character within a string. In case you also want to check if a character is in a string, right? You can use the find or you can use the in as we learned. So I can do something like, let's say, is A. So we can do something like this. Is A, right, in our string, right? So is A in our string? Is A in our string, remember? Right, is A in remember? No, A is not in remember. A is not a member of remember, right? I don't know whether I spelled this correct. So it's going to give us true or false, right? So false, right? Because A is not there. If a value is there, it's going to return E. So I can do the same thing here. So let's copy this one here and let's paste it here. I am talking so slow. Okay, so let's go with E. So E is E in this particular number. They're going to tell us that it is true, right? It can be in this particular number. Now, because we know that E is here, in case I want to find the position of E, I can also use the first method, right? I can use the first method of the number. So let's go this. Remember, as we did earlier on, then I'll just go with dot find. That's the first method. I'll pass in the E, right? It's going to find E for me. Is in the first occurrence of E is in this particular option 1, 0, 1. This is one method. I can also use the indexing to help us with that. So this is going to be off. The indexing is going to be like this option, right? So I can have it like the remember, which is a string that you are checking on. Nobody remembers how to spell remember. Dot index. So I go with dot index. Now I can also specify that particular index, right? So with E, I'm going to check for the index of the word, the index of E, the character E, among the string remember. Very interesting one, right? This is the same thing. I can also change it. So this is the first method and the second method. Very nice and very cool. So let's see. That is something very simple that we have done, right? So this one can also be used for this one, right? Using the index option. It's also going to work perfectly for us. So you have seen how to work with strings. Very interesting. It seems to have taken a lot of time, but by the end of this tutorial, you'll learn almost everything that you have to know about the basics of Python and then in programming also. Now, what if you want to check if a string has digits or alphabet? So how do I do that? So let's say my string, which is remember our famous word we are using today, in which we are making a lot of mistake in spelling it, because I want to check if it is having a string or if it's an alphabet. I can just go with is alpha. It's going to return true or false, right? So is it an alphabet? Yes, this is an alphabet, right? Very interesting. In case I also want to know if it contains digits, right? And also do the same thing. So I can copy this one here. As we know, remember doesn't have any digit, right? So if I come back to this place and I check it again, instead of is alpha, I can also do is digit. Is digit, right? Then if I do with is digit, let's try that one out. It's going to tell us that it's false because remember doesn't have any digit. What if you also want to check if it contains both alphabet and then digit? So that is where we use this option of is alphanumeric. So let's add something like is alpha, right? Then num. Is it an alphabet or a number? So if I go with num, alpha num is also going to print it out perfectly for us. Very interesting. So these are the various ways you can check if a particular string has digits, alphabet or alpha and alphanumeric, right? Very interesting. Now, what if you want to check for a string and what it starts with, right? So for example, let's say I have a string like alpha, right? And I want to check if it starts with A. So you can go with start with A. This is very useful in case you are trying to do natural language processing and you want to clean your text or search for a particular stuff. So this is going to search and tell me if alpha starts with A. It's going to tell me that it is true. It starts with A. Very interesting. In case I put B here, it's going to tell me that it is false, right? Very interesting, right? False. So that is something cool about that, right? So you can use start with. You can also do the same thing with ends with. So in that case, it's going to be alpha dot ends with. So in case I want to check if alpha ends with a, it's going to tell me that it is true. Alpha ends with a. Very interesting, right? Cool and very nice. These are very useful when you're trying to do natural language processing, and in case you want to search for a particular term within a script, right? Very nice. Now let's move on to the next option of how do we replace a particular value. So with Python, you can also work with replacing a particular string. So let's say I have a string like hello, right? Hello, let's say hello Python, and I want to replace, let's say, Python from that particular string. So we can do it this way. I want to replace this option of Python, right? And I want to put maybe a different way, like let's say instead of hello Python, I can say hello Julia. How do I do that? So you go with replace, then I'll specify the particular word I want to replace, which is Python, right? Which is the word here. Then what do I want to replace it with? That is a new word. So let's call this Julia. Let's make it capital. Right. I want to replace Python with Julia. So if I run it, now it's going to replace Python with Julia. Very interesting. So all that you have been doing, right? You have been doing it in this format, but you can actually store it inside a particular value, and then it's still going to work. So let's try that one. So if I store it inside a value, like let's say greet, right? Let's go to greet, and I say hello Python. Let's make it capital, small letters, right? Python. This same thing, you can also do the same thing. Then I can just do this greet dot replace. Then I can just pass in the particular word I want to replace, which is Python. Then the next word I want to replace is Julia, right? So it's still going to work, right? So either you do it this way or you do this way. This is just a variable that you have created, and you are doing the same thing. But the data stored there inside the greet variable is the hello Python. So if I run it, it's going to work and give us the same result, right? So if I go back to the greet now, so that now it's just giving us hello Julia, right? That's replaced perfectly for there's something simple that you have done. Now let's see how to split. So in case you want to split a particular word, right, which is very useful in case you want to do word tokenization or sentence tokenization, you can use this particular option. So let's say I have another word, like let's say the word is old, right? The word is old. I want to separate it. So with the space, if I go with this split, it's going to use the space to split the word is old, right, into a list for us, right? So this is what is behind this in case you want to tokenize the word. So in case you are searching something on Google, right? For example, like this, let's say I search for something inside Google. Anytime I search for something, let's say Google, right, it's going to tokenize them using the spaces. So let's try an example. So let's check for something like, let's say, so let's check for something like new iPhone, right? So see what is going to happen inside the browser. If I go with the new iPhone, so this is how it is. But if you check here, I don't know whether I can see it. Let's bring the, so at this place from here, it's divided them, right? New and iPhone, right? It divided them into it. So that's what is called tokenization. So one of the ways it does that behind the scene is to use a split. So it is splitting the new and the iPhone. There's a space there that splitted it, new plus iPhone, right? That's exactly the same thing that it is being done here, right? Very interesting. So with the split, you can split words into that. Then you search for the main one. Very nice. So you can also do another way. So let's try another one with the same thing. So let's use a new iPhone. So new iPhone, right? So in case I want to split by space, it's also going to give us the same thing, new and then iPhone, right? Perfect, just as we saw here. Very nice. So let's move on to what you are doing now. I can also split not just by space, but in case I want to split by e, right? Or I can also put the value here. So if I go with e, it's no more going to be splitting by the space, but it's splitting by e, right? So it's going to see the difference. And now n has been splitted on its own, w on its own, and then see how it has splitted it. So it is very interesting. So with the split, you can do a lot of this. Now let's check on string concatenating. So how do we concatenate a particular string? Concatenating means that you are putting a string together, right? You are putting things together. So the first method is, let's have something like my first name, right? Something like that. Or let's give it as a simple greet. And this greet is going to be hello, right? And there's something. See what I've done. So this is going to be, let's say, good morning. Good morning, right? Perfect. So, and I want to greet the person. So the person's name that you are greeting is going to be, let's say, John, right? In case I want to greet John, I want to join them together. You can also use string concatenating. So there are several methods. There are 4 different methods. So the first method is just use the plus. So if I go with greet plus name, it's going to add them together. So good morning, John. So this is, see how it has joined them. I'm going to see them as string and join them together without leaving a space. So this is a good method, but not the best method, right? It's not the best method. So the next method is to go with this option. You can actually add another space. So let's try that one out. So you can also actually add another space. So in that case, it's going to be like this. So plus, right? Then I'll add another plus. Yeah, so this is going to be an empty space here, right? So if I run it, it's still going to create it and add a space to it. So now we have a space in between morning and enjoy. Very nice. Now let's see the next method. So the next method is to use format, right? So in that case, it's going to be like this. Then I'll pass in the particular stuff I want to do. So this is the 2 different variables. So one for the greet and one for the name dot format. So with the dot format here, I can pass in my greet, then the next variable, which was the name, right? So that is the second method, and it's going to combine them in a very nice format for us. Very interesting. So with this option, I can even change it. I can bring the name here, the greet here, right? Very nice. That is the second method, right? That is one way of doing it. You can also try it out with this option. So this same thing I have done is for still method 2, we can do this also, which is another option. So in this case, it's going to be like this. So I can put in 0 here. So the 0 is referring to the first value here, right? Python starts from 0, not from 1. So it's when you're counting. So this is going to be 0 greet, and then this is 1. So I'll put in 1 here, right? So if I put it and I run it, I'm going to see that now it is working. Good morning, John, right? I can even add another one there. That is the advantage of this method. Then in this particular method, I can also put in, let's say, good morning, John, right? Then I can put in 0 there again, right? So it's going to know that this greet is the 0 and then 1 is the name. If I run it now, good morning, John, good morning, John, good morning, John, good morning, right? Very nice. That is something very cool with that. Now let's see the third method of concatenation of a string. So there's a new one called f-string, right? So f-string is started from Python 3.6 and upwards. So let's see how to work with it. So in that case, it's going to be something like that. The same thing that we did, right? The same we have done here, or the same thing that we have done here. But in this case, we are not bringing the format. We are bringing the f. You're not bringing this format. So we are taking out this. So I'll just copy the same thing here, right? For the f-string. And let's see how the f-string works. So the f-string is just like the format, but it's going to be the same as format string, but I'll take off this format, right? Then I'll just bring the f here, right? So this is going to be f-string. That's the first method. And now I can pass in my greet, just as we had here, greet here. Then I pass in the name, right? And it's also going to work. So Python will understand that this greet is a variable greet and the name is a variable name. Perfect. So if I run it, it's also going to give us the same result. Good morning, John. This is very, very powerful, right? The reason this is powerful is that you can do a lot of things with this. So I can also copy the same thing that I've done and do some powerful stuff here. So I can do this. Can actually convert the John to uppercase. So let's go as upper, right? And it's still going to work. To automatically modify the. So good morning, John. Very nice. So that is something very cool with the f string. So in case you don't want to use a small letter f, You can also use the capital letter F, which is also going to give us the same result, right? So I can make it a capital F and still going to work, right? It's the same thing, either small f or big F. All of them is going to work. That is something very nice about it. Now let's check some extras with a string model. So there are several packages that you can use. As you learned about the string model, right? You also have the Unicode. There are several packages, but let's work with the string model, right? That is going to be some extras with the string model. Perfect. So let's check it out. So just import string. And the string module gives us a lot of things to do. Give us the option of doing a lot of things, right, out of the box, right? So it's a standard Python library. So let's check it out. So I'll just go back here and let's work on it. I hope you are learning something. If you are tired, you can just go out and rest a little and then come and continue, right? Very nice. Now let's check it out. So in case I want to see all the various things I can do with this particular model, as we learned, just go with dir, right, directory, then I'll go with my string, and it's going to list everything out perfectly for us. So we have the formatter, right? You can format it just as we did above, or this formatting. In case you want to do more advanced formatting, you can use the string model, the formatter, or the template to help you do that. We can also have these particular attributes: ASCII letters, ASCII lowercase, uppercase, capwords, digit, hex digit, octdigit, printable, punctuation, and white space. So let's try an example. So in case I want to get all the alphabet, right? Maybe I'm doing something, I want all the alphabet. I don't want to type A, B, C, D, E. So I just go with my string dot, right? Then I'll supply the ASCII. So if I go with ASCII dot letters, as you see here, right? ASCII dot letters here, it's going to print all the letters for us, right? That is something very nice. All the English alphabet from the string model. If I go with ASCII letters, I'm going to print all of them for us so that I don't need to type A, B, C, D, E, right? All of them in both lowercase and uppercase. Very nice. That is something very nice. So the other options, in case I also want to get all the digits, I can also try that one out. So this is going to be, because I want to get all the numbers, right? 1, 2, 3 to the right. So do a string dot, then I'll supply the particular value, which is digit. So digit, and it's also going to print, like you see that we have digits here, right? So we can also do the same thing. Digits, right? It's going to count from 0 to 9, right? Very interesting. So we can also do the same thing for hex digit, octdigit, and the rest. So let's try that one out. Let's copy this one here, and let's try that one. Because I want to get all the hex digit, I can also do the same thing. You know that hex digit is totally different, right? It's hexadecimal. So if I run it, it's going to print it out in a totally different format for us. So these are all the hex digits, right? So it's going to count to 9, right? Then add the different hexadecimal numbers. I can't pronounce it. Okay, so that's how to work with it. Now let's see how to get all punctuations and special characters. So in case you want to get all punctuations together, you just go with string dot, not string dot, then punctuation. It's going to print all the punctuation and all the special characters for it. So these are all the punctuations, which is very, very useful in case you are trying to do, you are trying to normalize your text in case you are doing natural language processing, right? Very interesting. That is something very interesting about string. So you have learned a lot about string. Very, very interesting. You have seen how to work with variables. You have seen how to work with strings. Now let's move on to the next data structure, which is arrays or list, right? So what are lists? So lists are data types that contain items separated by commas and enclosed within a square space. So all that we did, so in case you want to create a list, just put it inside a square space, or you use this particular option of the list, right, to create it. The advantage of a list is that list can be of different types, unlike strict arrays. So in algorithms and data structures, we have in programming, right, you have arrays and a list. But the difference between arrays and a list in Python is that the Python doesn't have inbuilt arrays, right? To work with arrays, you have to import it. But the arrays is going to be an extension to the C array, the C type of array, or the Julia type of array. but Python uses list, and the list here is heterogeneous, and they are changeable. The reason they are heterogeneous simply means that they can take different types. So let's try and see how to work with it. So let's first of all create a simple list. So let's call it as, let's say, my list, right? So I can give it like, let's say, fruit, a list of all fruit. So this can be of the simple, this is going to be a simple list. So let's call it as, let's copy this one here. We first create a list of different types of simple type of the same type, another list of a different type. So this is going to be of the same data type. So a list can be of the same data type, which is usually, that is strictly, if it's a straight data type, then it can be called an array, right? So in this case, it's going to be of list, a list of strings of fruits. So let's give it a banana. That's the first. Then in this one, let's say apple. So we have banana, apple. Next one is going to be, let's say, mango, right? So these are the fruit that you are using. My spelling is failing me. Why? Okay. So that is how to create a list. So it's supposed to be inside a square bracket, right? Very interesting. So with this option, I've created a list of the same data type, right? So all the data types here is of the same type, right? So this is a homogeneous list. Right, so let's call this homogeneous list, right? So if I check, so this is a homogeneous list. If I print it out, it's going to print it out perfectly for us. So this is a homogeneous list. Very interesting. Now, in case I want to create a list of different types, so let's try that one out. So I'll just take off this one. Let's call it as my list. Right. So this can be of different types. So I can pass in numbers. Right. I can pass in a float, 4.5. It's another float. I can pass in a string. Right. I can pass in a string. So let's say awesome. Right, so it is taking a number, right? It can take a float, can take a string, can take several other aspects. So this is how to create a list, right? So you can even take emojis, right, or Unicode. So this is a list which is of a heterogeneous type. So that's the advantage about a list. A list in Python are usually homogeneous. No, they are usually heterogeneous. So this is going to be heterogeneous, right? That means I can take different data types. So if I print it out, if I print my list, it's also going to work perfectly. Right? So that's how to work with a list. So to create a list, just go with this option of the square bracket with your items separated by a comma, or it can be of the same type, which is strings, or any number, or it can be of a mixed type. The next method of creating a string, not a string, a list, is that you can also do this option, list, right? Then you pass in your tuple or your list. So if I go with this and convert a tuple to a list or a string to a list, any other stuff, so in that case it's going to be something like this, list. Then let's pass in 2, 4, 5. So this is a tuple. It's another way of creating a list, right? So this is a second method. So this is that it's going to convert it into a list from the tuple, right? So that is how to create a list. So this is how to convert a tuple, which we'll learn later, something like this, into a list, right? So this is the second method of creating a list, right? Very interesting. Now let's move on to how to check for the type of a list. So as we learned, just go with type and you pass in my list. If I pass in my list, or the fruit is going to give us that it is called a list. Perfect. Now let's check for the various methods and then attributes of a list, as we have been doing always. So I just go with dir, then I pass in my list. So you can see the various methods and the various attributes of my list. So you can add list, check all of these various stuff, and then you can also append, clear, copy. So these are the various methods, right, of our list. Very nice and very cool. So in case I want to check for the length of my list, just go with length and I pass in my list, right, and it's going to print it out perfectly for us, which is containing 4 elements. In case I also want to slice or index my list, I can do it my list, then the first 0. So this is going to be 0, is going to print the first one, which is 2. In case I want to do from, let's say, from 3 till the end. So we had 4, right? So I can, let's say, from 2 to the end, because our list is too small. I do it my list from 2, right, till the end. It's also going to work on it perfectly. It's going to print this particular one. So 4.5 and awesome. Very interesting. If I want to get the last 2 values, just give us the last 2 values. But in case I also want to do it, I can just do it list. And it's going to print the last 2 values for us. So it's going to be -2, right? As we learned earlier on, it's going to print the last 2 values, which is almost going to be the same thing, right? Very interesting. So that is how to create and work with a list. Now, how do you add to a list? In case I want to add a particular value to a list, there are several methods. So the first one is to add a list at one location, right? So let's say I want to add a list like we had our first list, which was, let's create 2 lists. So let's create my list 1, which is going to be let's say fruit and all of those things, right? Or let's use the first list we had and then fruit, right? We had these 2 lists. So if I print it out, you can see the various lists that we had. Right, so we had our list and then our fruit. So we have 2 lists. In case I want to add to any of these lists, right? The first method is I can add it at a time. So in case I want to add this another number like 5 to this my list, so let's go with this option. So my list, let's append, then I'll pass in the particular value. So let's say I want to add 50. It's going to add 50 to it, right? Now this number has been added to our list. So my list has been changed. So if I go back and I print my list again, it's now going to have 550 as part of it, right? So that 50 has been added to it. That is how to work with the append. I can also add a list to another list, right? So this is another option. So let's say I do it my list, right? Then I append another list. So let's say I'm going to append another list, like say 200 and then let's say 340, right? So this is going to be added at one location, right? Not at a different location, but at one location. So it's going to create another list inside this particular place, right? So that is the append option. Now if I go back to my list, the updated list, you can see that the difference, right? And now it has added the entire stuff. So the append is going to take any element you supply, whether it is a single element, multiple element, and put it at one location, right? So this is one location, no matter the number. So that is append. But in case I don't want it in this way, I want it in a better way. So 200 will go first, 24 will go next. Then we use the extend, right? So let's see how to delete this one. So let's delete the last value. So to delete the last value, just very simple. Just go to my list dot pop, right? Dot pop is going to delete the last value from it, right? So this is the last one that has been deleted from it. That is the last in. So it is called FIFO, right? FIFO. That is first in, first out. I don't know whether I can see it. So FIFO means FI, first in, first out. So this or LIFO, right? Lilo. Lilo, right? Last in, last out. So the last one here and the last one out. So anytime you go with the pop, you're going to pick the last one in, the last one out. That's the basic idea behind the pop. Very interesting. That's something to learn about, right? This is not part of it, but this is later on in the future. Let's make it like this, and then let's reduce this one to this. Okay, that is something very basic, right? Now that is how to. So if I go back and I print this one out, my list, it has deleted the last one, right? LIFO, right? So it is no more there. Now let's see what I mean by the extend. So the extend is you add an element one by one in a distant location. This one is adding it to one location, right? No matter the element, to one particular location. That is for the append. But for the extend, one at a time. So let's try that one out. So in that case, it's going to be something like this. So I have my list, right, dot extend, and now if I add a particular value there, right, no matter the value I'm adding, so if I add, let's say 2, right, let's add 2 and then the same value that we deleted, which was 200 and then 34 and then 54, right, it's going to add them one at a time. That is the extend. Now if I go back and I print this one here, my list, I see that it is added them one at a time, right? So that is different between the append. The append is going to pick no matter the element and put it at one location, but for the extend, going to take them one at a time and put them in their respective location, right? So that is different between the extend and an append. So to recap, let's give a simple example. So let's give a simple example to recap, right? So let's try that one. So let's say I have my even and my even, right, and I have my odd number, right? So these are the two lists I'm creating. So inside my even number and my odd number 3, 5, 7. That's for the odd, and for the even 2, 4, 6, right? So in case I want to extend it, right? So let's try that one also. In case I want to extend even number, even, let's make it like this option, so that at least you have something to keep with it, to keep with you. So I can just go with print extending, then I'll pass in the particular value. So we have my even number. In case I want to extend the even number, right, this is how it's going to be. In case I want to append it, this is how it's going to be. So in case I want to extend it with the odd number, so let's go with extend with the odd, right? That is for the extending. Now let's try the other one for the appending, so that you see the difference between append and then append. Can't spell append. Apologies for how slow it has become. Appending, right, and then extend. Perfect. So that is how to. So let's try it out. If I run it, you're going to see the difference. Hopefully it doesn't give us any error. So this, right, let's make it like this. The reason it gives us none is because we are inside a string, so you have to bring out the result out. So this is out. It's because we had a mistake. Let's change it, right? It gave us the none. So let's change. So I'm going to make it like this. I'm going to extend this one, right, with a new number, right? So I'm going to extend it with, let's say 8, 10, and let's say 12, right? That is for the even number. And let's try another one for the odd number, so that at least we have two different stuff. Odd. So I want to append the odd number with something different. So we append the odd number to the same values there. So we have 8, 10, and then 12, right? So that is something simple. So let's run it again. If I run it and I come back, let's check it out. So check for the even and let's check for the odd. You have to notice that we made a mistake somewhere, so the result may be quite different for some time. Perfect, right? See that this for the even number, this was how it is. So let's do some cleaning, right? So let's run it again because it gives us not what we're expecting. So I can just come back to the same place, run it again. Now let's check it out. So you see the difference between the extend and an append, right? Perfect. See that? So this is the extending. So the extending added them in their respective places, but the appending placed the entire stuff in one location. So that is the difference between extend and append. Now let's see how to sort a list. So how do you sort a particular list? So in this case, you have a list and you want to sort them. So let's go with our famous fruits. Then inside our fruit, we had banana first, right? Banana starts with B, banana. And then let's go with apple. Apple starts with A. Let's use a different fruit. So let's call it as nut. And another one, which is can be any other fruit. So let's give that one as, let's say, avocado, right? Or let's make it pear, right? Something like that. So these are BANP. So these are not sorted well, but in case I want to sort it, I can actually do that in a very simple way. So let's try that one out. So to sort it, let's go to fruit dot sort. It's not going to sort it alphabetically because all of them have the same data type, right? So the fruit is going to be sorted well, and then this is applying the sort function to the list. So if I run this fruit again, it is now in a good format, right? Perfect. So I see that now apples come first, banana, nut, and pear, because A comes before B. That is a very nice format. In case I also want to do a reverse sort, maybe I want a pear to come first, I can also do the same thing by going with fruit dot sort. Then I'll pass in my reverse is equal to true, right? So I'll tell them that this order is now going to be in a reverse format. So pear is going to be the first and apple is going to be the last. Now if I go back here and I check for the fruit, it's going to print it out perfectly for us. So pear is the first, nut, banana, and apple. So that's how to sort a list in Python. So in case you also want to insert an element into a list, how do you do that? So that is going to be very simple. So let's say I want to insert something. So let's create another list called companies, right? Let's give it the fan companies. Facebook also use Python. Google also use Python. Microsoft also use Python. And then the last one is, let's say, Amazon. Right? I can't spell Amazon. Amazon, right? Amazon also uses Python. So in case I want to actually, these are the lists I've created, right? I want to insert an element into a list. How do I do that? So let's insert JCharisTech, right? Our company to it. It's going to be my companies dot insert. Then with the insert is slightly different from append, right? Append is you are adding to it, or extend, you are extending it, but insert is you are inserting it to a particular position. So in case I want to insert Facebook, right, insert JCharisTech before Google, right? So it's going to be 0, 1, right? So, or 0, 2, right? So 0, 1, 2. I want to insert it before Microsoft, right? I can also do that. See how I spell Microsoft. Microsoft. So how do I do that? So in that case, it's going to be very simple. So I'll supply the position, so 2. Then I'll pass in my JCharisTech, right? So perfect. So if I run it, now it's going to insert it into that particular place. It's companies, not companies. Why didn't anybody tell me? Companies, right? So it has inserted it there. Now if I run this companies again, you're going to see it perfectly well, right? Perfect. So that now JCharisTech has been inserted in the position 2. So 0, 1, 2. Right, Microsoft is the next one. So that's how to work with list in a very simple way. So we have learned about lists. Now let's see another data structure called arrays. So in Python only have a list, right? But there's also an array option that you can also use, which is usually for homogeneous data, right? So this is something interesting about it. We only use arrays when you need a homogeneous C array of data for some reason other than doing math, right? That is the basic idea. So mostly you can use list, and it's recommended to always use list. But in case you want to be close to the machine or to expose a C array, then you go with the arrays package. So the difference between an array is that arrays are usually homogeneous for Python, but lists are heterogeneous, as we explained above, and they are flexible. So let's see some packages that can help us with that. So we have an array package, right? Then you can also use Numpy array to help you be exposed to the C array aspect of Python. You can read more from here to get more understanding. So when do you use a list, or when do you use an array? So you use a list if you know that the array will not change, right? And you want to expose the C array to a system call. So that means that you are going to use an array if you know that the array is not going to change. It's going to be the same size, same thing everywhere. But if you plan on adding items, as we have learned earlier on either inserting, extending, appending, the best one is to use a list, right? Because a list is more flexible, right? That is the basic idea. So that is something interesting. So I'll leave this one so that you can read on it. Okay, so let's see how to work with arrays. So to work with arrays, just go with import array. It's a package. then you can do a lot of things with it. So let's see the various things you can do in this particular package. So let's try it out. As we did earlier on the array, and you can see the various things you can do with it. It's going to give us several stuff. So we have the array, right, and the types codes, the type codes. So the type codes represent this particular one. So we have I for signed integer, we have F for float, we have D for double. So there are several codes that you can use to help you create an array of a particular type, right? So as we learned, arrays are homogeneous, right? Homogeneous, so you should specify the type. So when you are creating an array with this particular package, you have to specify the type, either as an integer, signed integer, float, double, or several of them. So let's create an array of only integers. So let's call this as, let's say, array, right? Then to create it, just go with my import. We have already imported array, so you're going to be my array dot array, which is referring to this particular array here, right? Then I'll pass in two stuff. So the first thing I'm going to pass is the type code, which is going to be the C type, right? The particular data type. So in this case, it's going to be I. So as we learned, I is for signed integer. Then I'll supply the various arrays that I want in the format of a list. So it's going to be this. And I'll pass in my integers. So it's supposed to be only integers. So 1, 4, 7, right? So these are my integers. Very interesting. So this is supposed to be array. Perfect. So if I run this one now and I go back to array, now this array is now only of one type, right? So very interesting. So this I means it's an integer. Very nice. Now in case I want to check for the type, if I check for the type here, my array, now it's no more a list, but this is an array, right? It's different from a list in this instance. So that's how to work with arrays in Python. Very nice and very interesting. But in case you want to do more with arrays, the best package to use is to use Numpy, right? So Numpy is a very, very powerful package you can use to help you do more with arrays. So with import Numpy as np. So to install Numpy, just go to the PyPy, then just do this option. All the packages that you are doing, in case you want to get just to install, just go with pip install Numpy, right? That is how to install Numpy on the system in case you don't have it. In case you want to install it from here, just put the exclamation here, right? In case you want to install it from here. But in case you also want to install it not from here but from your terminal, just go to your terminal as we did earlier on, then you paste it here, right? Same thing, right? Then that is how to install it on your system. Now let's move on, right? Okay, let's see how to work with Numpy. So Numpy has a lot of things, too much. A lot of things you can do with Numpy. There are a lot of things you can do with Numpy. So there's going to be a whole video tutorial on Numpy because Numpy is part of the advanced level 2 aspect of Python, right? So let's see the various things you can do with Numpy. So import, we are storing this is a variable we have created, right? That's the basic idea. So we'll learn about it later. So these are all the various things you can do with Numpy. Wow, there are lots, so much. Okay, now let's see how to create a simple array, right? So in case you want to create arrays of different dimensions, of different types, you can use this particular option. So this is going to be an array of 0 dimension, of 1 dimension, of 2 dimensions. So this is the first dimension, and this is the second dimension, right? Of 3 dimension, and the rest, right? So that is something very interesting in case you want to create an array. So in case I create this particular array, right? So array 0 dim, right? That is 0 dimension. This is going to be 42, right? Very interesting. So in case I want to check for the type, I can do the same thing. Then I can pass in my array 0 dimension. It's going to tell me the particular dimension it has, right? Which is a Numpy, a particular type it's having, which is a Numpy.nd array, right? That is n dimension array. That is the type of this particular data type. Very interesting. So you can do a lot of things with this. You can also check for the dimensions for this particular stuff. So this is for checking for the dimension. So to check for the dimension, just go with dot ndim. Go to print the dimension for that particular one, which is 0, right? So the same thing can be done for the rest. In case I want to check for the dimension of the array dash, let's say 2 dim, right? Just go with ndim. If I go with ndim, it's going to tell me that it's having 2 arrays, 2 dimensions, right? That is the basic idea behind it. In case I want to check for the size of this particular array, since it's still the same numpy array, I can also do the same thing. So let's copy this one here. This is going to be for the size. So just come back to this place, then do the same thing here as we did, right? So I can just do the size. It's also going to print the particular size for us, right? So that is how to work with numpy arrays. So the size is going to be the number of characters there, right? 1 2 3 1 2 3, which is 6, right? Very interesting, very nice and very cool, right? You can also check for the shape too, in case you also want to do that using the same option. This time going to be shape dot shape, right? So that is how to work with it, right? So the shape is 2 by 3, right? So 2 for the dimension, so it is the dimension, 2 rows, 3, and then 3 elements, right? So 2 by 3, that's the particular size. So 2 by 3, that's the basic idea. Now let's move on. 2 1 and then 2, then the element there is 1 2 3 1 2 3. That's the basic idea behind 2 by 3. That is something about arrays and something about numpy. In the future we'll be doing a whole video tutorial on numpy, which is very powerful. Now let's create, with numpy you can also do some interesting stuff. You can create a list of arrays of zeros, of ones, using the same thing. So np.ones, you can just create an array of ones, like as much as you want to. Let's say 20 by 20, right? So you can do a lot of things with that. So let's go to as ones. We're going to create only, it's giving us an error here. Let's make it like this. Yep. We're going to create ones, 20 ones, right? So if I go with print ones, I'm going to create an array of only ones, right? For 20, right? That is the basic idea. So you can do a lot for zeros and then the rest. So that is going to be in the future. So let's move on to the next data type, which is dictionaries. So what are dictionaries? So dictionaries are a form of associative arrays, right? That consists of key, value, pair. So they are the most important data structure, and dictionaries are usually very powerful. If you are doing most things, it's better you work and understand dictionaries. Dictionaries are very powerful. They are like hash tables, and they are also very fast. So to create a dictionary, just go with this particular option and then this option. Apologies for the noise if you hear any noise behind it. Yeah, I know you have been hearing some noise, but apologies. Okay, so now let's see how to work with dictionaries. So there's another powerful package in case you want to know more about and work more with dictionaries. Can go with the collections package. So let's see how to create a dictionary. So the first method of creating a dictionary, so the first method is going to be, let's create a dictionary called student, std. Right, I want to create a dictionary called student. Then so how do I create a student? So the first method is that we can use this particular option, parentheses, right? So let's go with this option. Then I can pass in first of all the name, right, of the student. So let's give it as Mark. Then the age, which is going to be another stuff. So the age can be, let's say, 23, and then we can also specify the place, right, that the person stays. So let's say the Mark stays in London. So that's how to create a dictionary in Python. Very simple. So this is now a dictionary. So it's giving us an error because we forgot to put this one inside a string, right? So that is the key. Perfect. So that is how to create a dictionary. Very interesting. So this is now a dictionary. So that's the first method of creating a dictionary. So if I check for the type of this, of my student, it's going to tell me that this is a dictionary, right? Dict, right? Very interesting. That's the first method of creating a dictionary. So this is the key and this is a value. Key, value, key, value. So it's an associative collection, right? Which consists of a key and a value. The second method is to use the dict option. This dict option. So how do we do the same thing? So let's try that one out. So in the same thing that you have done here, I can just copy the same thing here, right? That's the second method. Then I can just call that, let's say, student 2. Right, and I'll just put in the dict here. So this method may look redundant, but in some cases, in case you have a list and you want to convert them to a dictionary, you can use this particular option, right? So that is another way of doing it. So let's call this one as student 2. That is the second method of creating a dictionary. Now to check for all the methods of a dictionary, I can just go with the dir, and I'll just go with my student. Then you can see the various methods, the various things you can do, right? the basic stuff there, and then you can clear, you can copy, you can get items, you can check items, get all the keys, you can pop items, update and check the values. So to get all the keys in the dictionary, just go with my student, right, student dictionary. Then I'll just go with my dictionary. So in this case, it's going to be my keys. Right, so if I go with keys, it's going to list all the keys there. Right, so these are the name, age, and place. So these are the keys. So from here, you can see that the keys are these ones. So this name is a key, age is a key, place is a key. Right, very interesting. So that's how to get all the keys. Keys are also to get all the values. I can just go to student.values. Right, I'm going to print all of them for us. So this is a mistake. Student.values. Another mistake. Perfect. Right. So that is something interesting. So it's going to print mark 23 and learning. So these are the values. Again, in case I want to get all the items, right, I can also use the same thing option. I can either go straight away with it or use the items option to help me with that. So how do we do that? So it's going to be this student.items. So this is going to print all the items there, right? Just like a dictionary. Very interesting. So that is how to work with a dictionary. So you can even use the same method to create a dictionary, right? Very interesting. Now let's see how to find a value. So there are several ways you can use to find a particular value. So dictionary is just like the normal dictionary like we have here. Let me show you. So we have like a dictionary, right? So in case I want to find something, you can see from here that it's having a keyword, right, and the value. So in case I want to find it, I know where it is. So it's going to be very, very fast. So I know that B will be here, right? B will be here. So I made a mistake. B will be here, right? So I know that this is B. So in the same way, dictionaries are very, very fast, right? It makes it very, very fast. So let's work on it. So how do I find it? So there are several ways of doing it. So the first one is to use the indexing, right, or the bracket notation. So I can have my student. In case I want to find the name, I'll just go with the name. There is a key, right? So with this option, I'm going to find and print mark for us. I don't know why I'm making a lot of mistake spelling. Student. If you see any mistake, let me know. Student, right? So perfect. So this is mark, right? So it's able to identify the name, then brought the value there, right? That's how to find the value. That is the first method. In case I also want to, this is the first method. The second method is use the get option. So I can do the same thing. So student dot get, right? You realize that there was a get here. You know whether you remember? So there was a get option here, right? There's a get here, right? So that's what they're trying to use. So in case you want to get a value, you can also use a get option. Then you supply the particular value here. So you can supply the value, the key rather. By doing this, we're going to print it out perfectly for us. The advantage of this over this is that in case there's an error, right, in the bracket notation or index, it's going to give us a key error. But for this, it's going to return none. So let's see what I mean by that. So that is when to use it, right? So one of them will give you an error, another one will give you return none. So the bracket notation will give you an error. So let's try that one. So if I go with student, and then from here we have name, age, and place. So let's add something like email, right? So email is not there, right? So it's going to give us an error. Perfect. So that's giving us a key error. But because email is not there, but if I use the get option, if I use the get, it's not going to give us any error because the get is more powerful, right? So in case you are usually working with looping through, let's say, a dictionary, right, for a script, the best option is to use the get, so that in case it doesn't find it, your machine does not crash, right? Your program does not stop, right? That's the basic idea. So if I go with the same thing with the get option, dot get, then I go with emails, see that now, although it's not there, it not return any result, right? That is the advantage of the get. So the get is useful in case you're running a script and you want the program to continue in case it doesn't find something, right? And then a get is useful when you don't know the key, right? You can use a get, but the bracket notation is useful when you know the key. You know that the key is certainly there. That's the basic idea behind it. Now let's see some other stuff. So in case I want to iterate through my dictionary, how do I do that? So let's see a simple iteration. It's going to be for key for key, and then V for value in my student, right? I made a mistake again. In my student dot right items. So this option, I'm going to print out all of these things. So print my key and then my value. So see the mistake I'm making. Student dot items, then print K and then V, right? So around it is going to print them perfectly for us. A very nice format. So mark, the name is mark, age 22, place London. So that's how to work with dictionaries. Very, very powerful and very interesting. So dictionaries are very, very, very powerful. Now, how do you update a dictionary? How do you update a dictionary? So let's say you want to update our dictionary, which was our student. Let's create another dictionary. So my dict. So let's create another dictionary. So let's go to, let's say, name, as we did earlier on. Then let's pass in the name of, let's say, Paul. So I've created a simple dictionary like called my dict, right? And in case I want to update this particular dictionary, how do I do that? So let's say I want to add the age of Paul to it. So you can just go with my dict, right? Then I'll update it. So that is the option of doing that. So I can do that in this option. So I can create another stuff there for that. So let's call it, let's say, age dictionary, right? And I want to add the age of it. So it's called age. Then I pass in 23. Let's say BOD, date of birth, right? 33, I don't know, maybe 1999. So let's say 1998, something like that, right? I don't know whether it's correct, but let's take it like that, an example. So in that case, in case I want to add this age dictionary to this particular stuff to update it, I can just go with my date, that is dictionary dot update. Then I'll pass in the age. So this option is going to automatically add it to it, and should make sure that they don't repeat the names, right? They don't repeat the keys, because dictionaries are hash table, so they are unique, right? So perfect. So if I go back and I check my dictionary now it has updated it with the age dictionary. So you see that you see name Paul, job developer, age 23, date of birth 1998. Very interesting. So you have seen how to update stuff. So in case you also want to remove a particular task from a dictionary, you can also use the pop item or the pop. So let's try that one out. So it's going to be my dictionary, right, dot pop item. A good pop item is going to remove the last thing inside. So remember that we had this one, so it's going to remove this particular stuff there, right? Very interesting. So that is how it is. So if I go back and I check for the current dictionary now, it has been updated, then the date of birth is no more there. That is how to work with dictionaries. Now let's do some interesting stuff in case I have two dictionaries and I want to mesh them together, right? So let's say we have a dictionary. Let's create two dictionary. So we'll be using my dictionary, the first one. Let's create another dictionary, so dictionary 2. Then I want to merge them together with, so this one is going to be, let's say, salary. So his salary is $24,000. Then let's say his maybe salary, any other stuff that I want to add. So let's say I want to add his location, right? Something like that, where he stays. So in that case, let's say he stays in a country called Accra, right? Something like that. So in case I want to merge these two dictionaries for Paul and then this particular stuff, how do I do that? So this gave us an error because we always make that mistake. It's better you always put it in strings, except if it's numbers. Okay, perfect. So in case I want to merge them together, right, the first method is that you can use this option of, the first method is just go with this. So I have my dict for my dictionary 1, right? Then I want to merge it with dictionary 2, so it's going to be this option. So let's call this one as new dictionary. Let's call it as new, right? And I want to merge them together, right? So how do I do that? So in that case, it's going to be something very simple. I'll just create the same dictionary that we have. Now put in asterisk, right? And I'll put in my first dictionary, so my dictionary 1, or my dictionary first. Then the second one is going to be another asterisk. I'll pass in the other stuff. So my my dictionary 2. Right, so it's going to automatically identify the various keys and values there and then merge them together. So by bringing the asterisk and asterisk here, that is how to work with this. If I run it now, it's going to work perfectly without giving us any error. That is the first method. So from here, I can actually do this. Check the new dictionary. So new dictionary. Now the new dictionary has been merged together, right? So we're going to have it in a very long format. So you see that we have name, Paul, job developer, age 23, salary 24,000, location Accra. Very interesting. That is the first method of merging dictionaries. The next method of merging a dictionary is to use the same option, but in this case it's going to be something totally different, right? So you can just go with the same thing. So going to be my new dictionary, right? 2. Then in that case it's going to be dict. That is where you use the dict function. Then you pass in the particular stuff you want to do. So let's my dictionary 1. The M did not come. So my dict, right? My dictionary. Then I'll bring asterisk. Then I'll supply the my dictionary 2. So if I run it, it's also going to work perfectly. So this is the next method of creating or merging a dictionary. So if I go back and then I run it, it's also going to be the same thing as above. Apologies for the noise. I'll be breaking for some time. After the noise, then we continue. That is the basic idea about how to work with dictionaries. So in the next session, we'll be trying to see how to work with tuples. Okay, so now let's see how to work with tuples. So tuples are the next data structure that you can work with. So tuples are a form of sequence data type, right? Or a collection, and usually are enclosed within a parenthesis like this, right? This particular kind of bracket, or you can use this tuple option to create them. Then unlike lists, which are mutable, which you can change and update, tuples are immutable. You can only read, but you can't change them. So let's see how to work with it. So another package can also work with this name tuple package, which comes from the collections package. So let's see how to work with tuples. How do you create a tuple in Python? So the simplest way is just put them inside a bracket like this. So let me give an example. So let's go to T, right? TP for tuple. Then I can just pass in any value. So it can be 2, 5, 6. So this is a tuple, right? Very interesting. So this is a simple tuple. In case I want to check for the type, let's go with type. Then I pass in TP. Then it's going to give us the type as a tuple because inside this particular bracket, right? Very, very interesting. So I can also do check for the types, the methods and attributes of this particular tuple by going with dir TP. There's going to list the various things we can do with them, which is the basic stuff there, as well as these ones, right? So you can't do a lot of things with tuple because it is immutable. You can only count them and then find the index, right? So in case I want to check for the length of a tuple, just go with length, my TP. I'm going to list it perfectly for us as 3, right? Very interesting. But what about if I want to index them, right? Tuples are immutable, so you can't change them. You can index them, but you can't change them. So in case I want to get the first value, right, as we did by just from 0, we're going to get it, right? But I cannot change it, right? It is 2. That is something about it. So they are immutable. So let's try an example of that, right? So let's say we had our tuple like this. Let's create another tuple. So let's create another TP2, right, for tuple. Then this is going to be a tuple like, let's say we have 20, right? Then let's part in, let's say hello. So this is a simple tuple, right? In case I want to change it, I want to change the hello, right, to maybe hola. It's impossible. So if I check TP2, 0 is going to give us as 20. Very interesting. So in case I want to get to hello, I'll just go to 1. But I cannot change it. I can read it, but I can't change it. So in case I want to change it to, let's say, hola, it's going to give us an error, right? Type error. So you can't change tuples. Tuples are immutable, unlike a list in which you can change them, right? That is something very interesting. So with a list, in case this was a list, you could have changed it, but with a tuple, you can't change it. So let's see an example. So this is, let's say, something we forgot to do. So L1 for list. So in case this is a list or this is a tuple, right? I have this tuple here. I want to convert this tuple to a list. I can just go with list. Now pass in TP2. 2, right? So this is now going to be a list. So this is how to convert a tuple to a list, as we learned earlier on. So that the only way of changing a tuple is to convert it to a different data structure like a list before you can actually change it or make changes to it. So this is converting tuple to list, right? So that is the only way you can change it, right? So in this particular option, I can actually change it. I can make some changes to my list. So this is no more a tuple, this is now a list. So L1, perfect. So we said now L1 is now a list. In case I want to change hello to hola, which is 1, then I can now put in the particular value there, which is going to be hola, right? Yeah, I think that's how we spell hola. This is the wrong spelling, and now it is working perfectly. So if I go back to my list, it has been modified, right? So tuples are immutable, but lists are mutable. So that is the basic difference between them. So there are some other extra things you can do with it, with tuples, but these are the most common ones, right? The most common ones you can do, right? Because it's actually immutable. So these are the limited stuff you can do. Now let's see some other extras with another package called collections. So with collections, you can also do some interesting stuff about tuples. So a name tuple is a format of a tuple, but it's in which is being attached to a particular name, right? So named tuple. So tuple attached to a name. Simple. So let's try it out. So to work with name tuple, just go to import collections, right? So with collections, you can do a lot of things, not only just name tuples, but all the Python data structures. So let's see how it is. You can do more with it, right? So all that you have done so far about the sequence data types, you can use collections to boost it up to do some interesting stuff. So let's try that one out. So if I go with with collections, I see the various things that collections has, the collections package has, that we can use. So collection, that's a nice name. So we see that we have chain map, counter, ordered dictionary, user dict, user list, user string. So these are all the various things you can do with collections, right? So these are extra data types: name tuple, double queue, right? Decree. This was another stuff. So let's see how to work with name tuple. So to declare a name tuple, just go with, let's first of all import it above from collections. So it's going to be from collections, import named tuple, right? And with name tuple, you can create something like a class, which you can use to create different stuff, because it's a name attached to a tuple. So you can use to act like a blueprint to create different objects, right? Which are name tuples. So let's try an example. So let's give it as, let's say, people, right? So you are creating a name tuple called people. Then this is going to be our named tuple. Perfect. That's the first stuff. And I'm going to give it the name that I want to use. Right? So this is going to be the people. You can't spell people. Then from here, I'll give it my list of stuff I want to use. So I have my attributes, right? So the first one is going to be the name of the people, then the age, and then let's say the grade, right? So these are the three stuff there. So this is going to create like a blueprint, which is a name tuple, so that I can use to create different name tuple objects. So that is how to declare a name tuple. Very interesting. Now I can, if I go with people like this, it's going to print it out perfectly for us. So you see that this is the main and this is a tuple. If I check for the type of this tuple, right, it's going to tell me that it's a type people, right? It's going to tell me that it is a type, right? So I've created my own particular name tuple type, right? Very interesting. So with this particular type I've created, I can keep on creating different types and adding value to it. So let's try an example. So if I go with P for people, with people I can just go with the same thing as people, then I pass in the first one was name. People, right? People, anyhow you say it. The first one is a James. The next one is going to be the age, and then the next one is going to be the grade, right? So the grade was A, right? So if I want it, it's going to create and add the value to it. Now I can actually view it. So if I go with the P, now this P now is a name tuple object. So let's check it out. If I go with P, you can see that it is going to have, these are the names, right? So it's a tuple, as you can see, but it's having values that have been attached to a particular name, right? So these are the names that have been attached to it. Very simple. Now I can also check for the type of this now with type P, as we did earlier on. Then it's going to tell us that it is now, the type is people, because it has constructed, when we call this people type, it constructed a people type, right? So that is why it's given us this particular type, unlike this one that is given us a type. So how do we access it? So you can do a lot of things with it. So let's check for the various attributes of it, like always. So DLR P, so I can see the various things you can do with it. So there's going to be an assignment that you can actually work on it. So you see that you can, these are the attributes, the age, count, grade, index, name. So name was there, grade, count. So these name and age and count were part of the things we created. So name attribute, age attribute, grade attribute, and it was added to the attributes there. Very interesting, right? That is the power of name tuple. So which name tuple can even use to create classes and objects to do your stuff. Now, how do you access your value? So to access your value, just go straight away with, let's say S is a name tuple, right? So it's very interesting. So we will P dot the particular stuff. So we had name here, so you can actually access that particular value, right? So that's now an attribute. So P dot name, okay, because we left a space. Perfect, right? So James, right, which was what we stored there, right? So that's how to access using the index. This is using the name, not the index. To do with the index, so let's copy this one here. Go with this. To do with the index, it's going to be the P. Then I'll supply the index that I want, right? So index is 1. It's going to give us the particular value for 24. In case I want to get the name, there's going to be very interesting. So James. So to get it using the name, just go with this particular option. And it's working perfectly. So there's also another option using the get attribute option. So in that case, it's going to be, let's say, print, then get attribute, right? Then I'm passing the particular class I've created, particular name tuple I've created, the object, and I'm passing the attribute I want. So the attribute I want here, let's say, from here we could see that we have several attributes here. We had grade, so in case I want to get the grade, I can also use the same option and pass in that particular stuff here. So it's going to be this. So I made a mistake, grade, right? I'm going to print it out perfectly well. So that's another method of using it. So you can use the index. If you know the index, you can use the name. If you know the name, you can use the get attribute function to get it from a tuple. So that is how to work with tuple. So the next session we'll be working on sets. So what are sets? So set is an unordered, unindexed collection. Unlike a dictionary or a tuple, sets are unordered and then unindexed. So it's very, very powerful to create a set. To just go with this particular option, but with comma separated items, right? That is the difference between a set and a dictionary. Although it's having almost the same thing, but sets are usually unordered, unindexed. It's not a key value. It's just a collection of comma separated items. The next option of creating a set is just go with this particular option. So let's do some math. There's something interesting. So this is how a set looks like in mathematics. So in case you are given an assignment, you can use this option to help you work with it. So this is how to create, this is how a set is, right? So a set consists of elements. So these are the elements, different elements, and then you can just do the same way in mathematics. So this is how to do that in maths. In Python, you can also do the same option to create a set. So we have, it's an element of this option and this option. So these are something very big about set. So let's see how to create set. So these are some extra packages in case you want to plot a Venn diagram or to work with set. So the first method of creating a set is, as we learned here, something like this, right? So let's see an example. So let's create a set of all numbers. So it's going to be like this: 0, 1, 1, 2, 3, 4, 5, right? So this is a set of all numbers: 3, 4, 5, 6, 7, 8, 9, right? So this is a set of all numbers, right? Very interesting. That's how to create a set. That's the first method of creating a set. Very simple. The next method of creating a set is to use the set function, as we learned earlier on, right? So in that case, it's going to be like this. So let's go to as even numbers. Which is going to be like even numbers, right? Then I'll pass in this option. So in that case, it's going to be the same thing. Set, right? Then I'll pass in a list. So I'm going to convert a list to a set, right? So this is going to be 2, 4, 6, 8. So this is another method of creating a set. Using the set, then you pass in a list, right? So this is going to be from list to set, right? Very interesting. That is how to create sets, right? So let's check for the type of what we have. What you've done so far. So if I check for the type of this, is going to be type of my even numbers. Now I'm going to see that it is a set type. Very interesting. So that is how to check for the type. Okay, so let's see the various methods you can also do with it. So let's take off this, the various methods. So dir, we had our even numbers, and let's see the various things you can do. So you can do all the basic stuff plus this stuff. You can check for, you can add to a set, you can clear it, you can copy, make a difference, discard, intersection and update, check all of these things, do you know? So almost all the basic mathematical stuff and arithmetic can be done with set. So let's try an example of how to add to a set, right? So let's say I'm going to create another set. So we have our even numbers, right? Even numbers. So this was our even numbers set that we created. So in case I want to add, let's say 10 to it, right? I can just go with this, then add 10. So if I go with this, now it's going to update it and add 10 to it. So if I come back and I check it, now even numbers is having 10 as part of it, so that's been added to it. That is how to add to set. Now in case I want to remove it, so there are two options. You can use the remove or discard. The difference between the remove and the discard is that the discard doesn't raise an error if it's not found, just like the get, but the remove is going to raise an error, right, if it's found. So if I go with even numbers dot remove, so let's remove number 2. If I go to remove 2, it's going to remove it. Now if I go back and I check it back, 2 is no more there, right? So it has removed it perfectly from there. So it's only 4, 6, 8, and 10. But let's see how to do the same thing with discard. So with discard, if I go with even numbers, let's remove 2 again. 2 is no more there, so it's going to give an, it's not going to raise an error, right? See what I did. Dot discard. It's not going to raise an error, right? Because 2 is no more there. It's not going to raise an error. But in case I do the same thing with remove, let's try that one out. Let's try that one out. So even numbers dot remove. If I do the same thing with remove 2, because 2 is no more there, it's going to give an error, right? So that is the difference between the discard. It's going to give a key error. So that's the difference between the discard and then the remove, right? Something very basic, something very interesting. So in case I want to remove the last option, right, from it, since they are unordered, right? Unlike a list, the last FIFO, right, LILO, LIFO, FIFO, unlike a list in which FIFO, LIFO works for set, is going to randomly pick anything. So if I go with even numbers, right, we have even numbers. In case I want to remove one out, it can pick any, it can pick 4, it can pick 6, it can pick any. So if I go with even nums.pop, it's going to remove anything from it, right? Going to delete anything without stuff. So you see that it took 4. It could have taken 10, it could have taken 8, it could have taken 6, but it's going to take any because it's unordered. So there's no rule based on this, right? There's no rule on how it removes it. Even nums. Now 4 is no more there. 6, 8, and 10. Very nice and very interesting. So that is how to work with set. So in case I want to remove all the elements, not delete the element but remove them, I can just go with the same thing with the clear. So even nums.clear, going to clear our set, and a set is going to be an empty set. So if I go with even nums, it is still there but it's empty, right? That is an empty set. So that is how to remove all element with a set. But if in case I want to delete it, I just go with the delete, then to delete it perfectly. So del even nums, then it's gone, right? So now if I run it, it's going to tell me that it is no more there. Oh, I deleted it. Okay, let's paste it back. So it's no more there. We use the del even nums to delete it. Now in case I check it back again, it's going to tell me that there's nothing there, right? Name error because it has been deleted from memory. So that is how to delete something. So this is going to use to delete it from the memory. So it's no more there, right? So I have to define it again. Very interesting. So let's see how to work and do some math with sets, right? So in case you are given an assignment and you want to do union of set, intersection of set, difference of set, let's see how to work with it. So this is a picture to show you about them. So this is a union of set, right? Set A and set B. Another one for an intersection of set A and set B, and then the rest. So there are several of them, right? So you can just check it out and see the various stuff. So let's see how to do a simple union of set. So this one doesn't change the set, right? So let's create 2 sets. I'm going to call it as A, set A. That's another way of creating it. So the set A is going to be 2, 4, 5, 6, 7, right? Well, let's create another set B, just like we have it in the picture here, right? And let's use the next method of creating a set. You can use the first method or second method. So this is going to be of 3, 1, 3, 4, 5, 6, 9, right? So we have 2 sets. We have created A and B. So in case I want to unite them together to build a single set, right? We can use the union option to help us with that. And one thing about it is that this is not going to affect the previous set. So if I go with union of A and then set A and then union B, it's not going to affect A. So the B was wrong. It's supposed to be capital. So this is the union of them, right? It's going to unite them perfectly together. There's not going to be any repetition. So that is the advantage of set. So in case you have a list of words and you want to find the unique values, you can just use set. Then it's going to pick only the unique values without replication, without duplication, right? So that is the basic idea behind a set. So let's say I have something like, let's say something simple. So let's say S is going to be a simple list. We're just having a word like A, B, right? And A, and let's say something like C, right? So from here, this is a simple list, right? In case I want to find the unique values in this, I can use the set to help me with that. So in that case, it's going to pick only the unique values without the duplicates. So I go with set S, only A, B, and C. It's not going to repeat them, right? So that's the advantage of set. So you can use set to find the unique values and to avoid duplicates, right? That is something, by the way. So this is the union of it, but the A has not been changed, right? It doesn't change the previous value. All of them are going to remain the same. If I go with this, it's going to still give us 2, 4, 5, 6, 7 without changing it, right? That's the union. So let's see how to work with, in case you want to change it. So in case you want to change it, then you use the update. So in that case, it's going to be a.update. Then I pass in the particular stuff I want to do, right? It's supposed to be update. So if I pass in something now, it's going to add it to it. So let's pass in another value, like let's say 10. Now it's going to add it to it. So it's supposed to be a set, right? You can't just put in a value, you can just put in an element. So let's put in this option. So we are putting in number 10. So this is going to be another stuff you are putting there. So this is another mistake. Forgot. Right, so it's now going to add this particular set to it. So if I run it, it's going to add the set 10 to it, right? So if I go back and I check the update, now A has been affected, right? So now we have the number 10 as part of our set. Very interesting. That is how to add to your set, right? Either by using the union or using the update. But the update will change your initial set, right? But the union will not change it. Now let's see how to do intersection of set. So in case I want to do intersection of a set, right? Just like we had here in the picture, this is an intersection, right? In case I want to do an intersection like this, how do I do that? So it's going to be in this particular option. So I'll just go with a dot intersection is too long, right? And I'll pass in the B. So I go with that, it's going to give me an intersection of them. So only 4, 5, 6 were intersection, right? Very interesting. You can also do subset and check if a word is a subset of another. So let's see something like, let's create another one called C, and then inside C I'll just put in 2 and then 4, right? 2 and 4. So in case I want to check if C is a subset of A, I can just go with C, right? Dot is subset of A. So in this it's going to give us true or false. So true, right? So 2 and 4 can be found inside A. 2, 4, 5, 6, 7, 8. That's the basic idea. That is how to work with subset, right? To find a subset. You can also check for the difference of a set. In case you want to check and find the difference between the sets, you can also do the same thing. So we have A dot difference, then I pass in B. So I spelled it wrong again. Difference is going to check it for us and give us the difference. So 2, 7, 10 are the difference between A and B, right? There are other stuff you can also do, but these are the most common one. Then you can also do a disjoint test to check if this disjoint. So it's going to be C dot is disjoint. Then I'll pass in, let's say B, right? True or false. These are Boolean. False. Very interesting. That's the basic idea behind all that you have done so far. Now let's see how to plot a set. So this is an extra stuff. So to plot a set, just go with this particular package. So pip install matplotlib, right? So to install this particular package, just go with this option of pip install matplotlib. Right, so that is how to install this particular package, right, to work with it. So let's see how to plot a Venn diagram, right? So it's very, very simple. So just go with, let's import matplotlib. So it's going to be import matplotlib dot pyplot as plt. Perfect. Then from the particular Venn diagram, you'll be plotting the various stuff, right? So from matplotlib underscore ven import ven2 for Venn diagram in case you want to create only two circles, ven3 for 3 circles, and the rest, right? So that is something very interesting. So let's see how to work with it. So hopefully there's no mistake in it. Perfect. So in case I want to plot my graph that we had there, right? So how do I plot it? So the simplest we just go with ven2. I'm creating 2 plots. Then I pass in my a, right? The 2 set I had. So I had my a and I had my b. That is how to plot it, right? So this is the first way of plotting it, but I have to give it a name so that it will be clear. So in that case, I'll just pass it here. This is supposed to be a function, not a list. So inside this particular function, I'm passing in this stuff here. Right, I'm passing in my Venn diagram A and then B, and then from here I will pass in the labels. So this is going to be another label, right? So let's give it as, let's say, set A, set B, right? So that you can see the difference. So in case so that is how to create a Venn diagram. So using a Venn2, and these are the values, set A and set B, and these are the labels, right? Perfect. Now to plot it, with plt.show, then it's going to plot it perfectly for us. Very interesting. So that it was able to plot our set A and B in a very nice format and give us the intersection, right? So that's how to plot it in a very nice format. This is one way of doing it. In case you also want to set the labels, you can also do the same thing here. So the same thing, right? Then you set the labels. So instead of using this, you can also use set labels, right, for the label that you want to use. Then you pass in the particular value, right? So there's another way of doing it. So any of them is going to work perfectly, right? Then you do a simple plt.show to plot them. To either use the first method or the second method, right? Any of them is going to work. So that is how to plot a Venn diagram in Python, right? Using matplotlib Venn. Very interesting. Now let's move on to conditionals. Then you move on to functions. Then you end, because it seems we are taking a lot of time. So let's see how to work with conditional. So a conditional is just as the name goes, a conditional, right? So it has to do with if, else, if, and then else, right? So just normal conditional statement. Then usually it must obey indentation, and then you can actually nest them. So let's see a simple condition. So for example, conditions are very, very important in programming to help us make decisions, right? So if it rains, go to the house. If it doesn't rain, stay, right? That is the basic idea, just like English. So let's see an example. So let's say something very simple. So let's say that I have something like, let's create a variable. So let's give some values here. I'm going to give 2 values, right? So we have s is equal to 40, and then y is equal to 20, right? So these are 2 values. I want to create a rule, a condition for them, right? So let's see how to do that. So let's say that if my s is equal, just like English, if my s is equal to 40, I want you to print, I want to do something, right? So what I want to do is I want to print, so s is equal to 40, right? So that is how to create a simple if condition. So if s is equal to 20, print this. It's going to print it perfectly for us. Perfect. S is equal to 20 to 40, right? That is something very interesting about creating a simple if condition, just like English. So if this is true, do this. Very nice. Mostly in creating if conditions, you use the logical operators to help you with that, right? The same way I can also add an else. So if s is equal to 40, print this. Else, print not true, right? Something like that. So, or not equal. Can t, let's say, less than 40, something like that, right? So you can also do something very simple to help you with that. So with the else, so the else is going to be the option if it fails, right? So if I run it now, it's going to print it s is equal to 40. But if I change here from 40, right, to let's say 30, right, and I run this one, it's going to give us s is less than 40, right? Very interesting. So that is a conditional, right? Very simple. So if, then your condition, then your result, right? If it fails, give us the result. You can also do for multiple if conditions, right? So in that case, let's copy this one here. Then this is going to be multiple if conditions. So you can do it like this option. So let's take off this. Right, let's take off. So if s is equal to 40, print this, right? Or else if, that is else if, or you can also make it like this. If, but the recommended way you just go with else if, right? S is equal to 40, or let's say s is less or equal to, so less or equal to a particular value, right? Less or equal to, let's say 20, 30, right? Print yes, something like that. So if I run this one now, it's going to check it and give us yes, right? Very interesting. So that is if else, if else, if else. Very interesting and very nice. That is how to work with conditionals. Very, very simple. You can nest them and do a lot of things, but this is the basic about it. Now let's rush through to the ternary operator. So ternary expressions are usually just like if conditions, but they are in one line. So they are also called one line if statements. So the basic idea is that you just give your result if it is true, your condition, then your result if it fails. So let's give an example. So in that case, it's going to be something like this. So I can say print enjoying it side, okay, enjoying the video, something like that. That is a result if it's true. So if, then you give your condition. So let's say if my y is equal to, remember that we define y above, we define y as 20. So if y is equal to 20, then I want you to print this. So if it is true, if my condition here is true, give me this result, else give me this result. So if my condition is true, if y is equal to 20, give me enjoying the video, else not so. Not so, right? Something like that. So let's go with print. And it's going to work perfectly for us. So that now enjoying the video. So that is how to do a ternary operator. So the result if it is true, and the result if it fails. Very nice. So that is the basic idea about conditionals. Now let's see how to work with for loops. Then we move on to working with functions. So a for loop. So a for loop is used for iterating over a sequence, right? So it works as an iterator method. So to work with it, just go with the syntax of for, and can be used with break, continue, else, and pass. So Python is just like English, right? So let's see an example of a for loop with a sequence. So it's going to be very simple. So let's say I have a sequence of languages. So let's create that one. A list or a sequence can be a list or any other collection. So let's create of languages, right? So it's going to be languages. And these languages are going to have all the programming languages that we have. So we have JavaScript, which you'll be learning later. We have Python, which is what we are learning now. And Julia, which you'll be learning after this. And then let's say Go, right? Which you'll be learning in the future. So these are the languages that you'll be learning. So these are the languages. So in case I want to iterate through this sequence, loop through them, right? I can just go with for, right? I can be K, can be any name. So for language, right? Singular. In my languages, it must always have an iterator because it's an iterator method. So this is the list, this is the sequence. Then I just go print the lang, right? If I go with print the lang, it's going to loop through this and print everything out perfectly for us. Very, very interesting. So it can be used to do a lot of things. I can actually modify these things I'm done whilst iterating through them. Right. So in case I want to iterate through them, I can also modify them. Like in case I want to modify those things here, I can also make it like, let's say, lowercase. Right. And it's going to loop through them and convert everything to lower. Right. Very interesting. So you can do a lot of things with for loop. Very nice. Now, how do you loop through a string? So let's see an example. So let's say for I in the particular string I want to loop through. So let's say hello. Right. I want to loop through the string. So this is simplest way. So print I. That's going to loop through this particular string. So that's how to loop through a string. Very nice and very cool. So that is how to do that. So in case you want to skip a particular value, just as we had here, you wanted to skip, let's say you want to skip JavaScript or Python or something, right? How do you do that? So that is where we use the break option, right? So we use the break to stop the loop before it iterate through all the items. So let's see an example. So it's going to be, say, for lang in my languages. So that is it. I'm going to say that print the lang, right? Print all the languages, just as we did. So this is going to print all the languages there. Perfect. But in case I want to break when it reach Python or when it reach Julia, then I'll just pass in an if condition as we learned earlier on. So if my lang is equal to, let's say, Python, or is equal to, yeah, if it's equal to Python, I want you to break. So if I go with break is also another keyword. It's going to stop, right? So if I run it now, only JavaScript and Python is going to be. The rest is not going to come. Julia and Go is no more going to come, right? That's the basic idea with the break option. In case I want to continue, I can also do the same thing. So let me copy this one here. Then I'll use the continue option. So the continue is used to continue something until you meet something, right? So let's say this option. Let's take out the print here. So if language is equal to Python, continue. Instead of break, continue. Something like that. So we can use continue to also help us with that. Not continue, making a lot of mistake. Then I can just print it out. Print lang. So you can break it or you can also continue. So it's going to print it. So JavaScript, Julia, Go. So Python did not come, right? Very interesting. So that is the basic idea behind using for loop together with conditions to break, to iterate, and then to continue. You can also pass in case you don't want to. In case you don't want to do anything, you can also pass. So for example, something like this, say for lang in languages that you are going to be learning, pass. So I go with this, it's going to go straight away without giving us any result. So you can also pass. So we have seen how to work with for loops. Now let's see how to work with range together, right? So we can also use range together with for loop. So so range can be in several formats. You can have range to get a range of numbers, right? It's going to be from 0 to that particular number. That is in case you specify only one value. In case you specify two values, it's going to be from the start to end. In case you specify three values, it's going to be from start, end, and then a step. So let's see an example. So if I go with range 10, it's going to print from 0 to 10, right? Perfect. Then in case I want to get from a particular value, so range, so I want to start from 3 to 30 or 20. I'm going to start from 3 to 20, right? So this is the start and this is the end. Again, in case I want to give it a step, right? Let's say I'm counting from 0 to 20, but step every 2. Give me 2 steps or 3 steps. So in that case, it's going to be this option. Let's correct this one. So in that case, it's going to be my range. The first one is going to be my start, 0. The next one is going to be my end, right? So let's say 20. And this is going to be the step. So the step is going to be, let's say, 3, right? So that is the basic idea. So it's going to start from 0 and end at 20, but it will be given an interval of 3, right? That's the meaning of the step. So let's see how to loop through them. So in case I want to loop through the range, it is going to be like this. So for I in my range 10, as we did earlier on, print I. If I go with print I, it's going to actually do that perfectly. So that's printed everything for us. So 0 to 9. Very nice. I can also do the same thing for the step. So that case is going to be for I in. Cool. So the for loop usually is an iterator method used to loop through sequences and collections, right? So for I in my range, so let's use the one we did. So 0, 23. So this is only going to print 3 steps, right? With an interval of only 3. So it's going to be this option, print I. So now it's going to have 0, 3, 6, 9, 12, 15, right? That is how to work with ranges and then for loops in Python. Now let's see the next loop method, which is while loop. So while loop is used to execute a set of statements as long as a condition is true, right? So it has a keyword while, so you can use it just like for loop with break, continue, else, and pass. So let's see an example. So it is very, very simple with a while loop. So it's going to be very simple. So this is how to work with while loop. So we're going to specify your condition. So let's say I is equal to 1, right? That is it. So execute a set of statements as long as my condition is true. So while I is less than 7, right? I want you to keep on printing. So print I, right? That is the first thing. That is how it's going to do. Then I have to iterate it, keep on adding to it. So how do I do that? So I can do it in the simplest way by going to I is equal to I plus 1. This is part of the add end that we did, right? The add end that we learned previously. So if I go with this option, it's going to keep on adding 1 to it till it reaches this particular option. So let's go to 7. We forgot the 7. So while I is less than 7, keep on printing, right? It's going to print till it reaches 7. So this method can also be done in this particular option. So I, the add end option, is going to be plus 1, right? This thing is the same thing as this. This is the simplest format, and this is a long format, this is the simplest format. It's going to work perfectly for us. That's giving us the same result, right? Very interesting. So that is printing it like that. So this is supposed to be this. So to keep on printing till my machine crash to the end of the world. So that is why we always bring this one. Otherwise it will crash, right? So if I run it, it's going to end at that particular position for us. That's the basic idea about working with while loops. Very interesting. So this thing is the same as this thing, right? Without this, it may crash. So you have to make sure that you have to know when to use while loop. Otherwise, you will always be having a lot of mistakes. Okay, so now let's see how to work with functions, right? So you see that it's working perfectly. 1, 2, 3, 4, 5, 6, 7. Perfect. So let's see how to work with functions. So what is a function? So in functional programming languages like Julia and the rest, function is very, very important. So a function is a block of code which only runs when it is called, right? In Python, it's usually defined with the def option. So let's change it. Too much of the white. Let's change with the black so that we miss it. Abby. So welcome back. So we'll be learning about functions and then we'll be ending soon, right? Because it seems we are taking a lot of time. Okay, so very nice. Now let's see how to work with functions. So as we learned, function is a block of code that does something when it is called, right? So that is the basic definition of a function. So let's see how to work with it. So that is how to define a function, right? So in working with function, you can define a function or declare a function. You can also call a function. And the functions usually have arguments or parameters in which we work with. So a parameter is a variable listed inside the parentheses. So let's see an example of it. So let's see how to define a function. So let's work with something very simple. So it's going to be like this, def, right? Define. The def means define. So define a function. Then let's call that particular function something simple, right? So it can be any stuff. So let's call this my function, right? And I'll pass in. It can be an empty function like this. And let's go with print. Hello Python. Pythonistas. Pythonista is anybody that works with Python, right? So this is a simple function. So that is how to define a simple function which is not having any argument, right? So there's an empty, it's a simple function without any argument. Very, very interesting, right? Very nice. So this is used to define a function. So def, then the name of the function, then the parentheses. So inside here, you're going to pass in your parameters. So in case I want to call this particular function, I just go straight away with my function with the parentheses, right? With the brackets. Then it's going to print hello parentheses. That is an empty function. Very interesting. A function without a argument. Very nice. That is how to define a function. Let's see another way of defining a function. So with a parameter in this case. So let's come back here. So this is going to be a function with a parameter, right? Define a function with an argument or a parameter, right? So the parameter is what to be placed inside this particular place, right? It's also called the argument. So let's give it as the same name. So now hello Pythonista. So instead of hello Pythonista, let's pass in the person's name here. So in this case, let's use the s string, right? Then you pass in the name just as we did right previously. So hello, then a name. So this is another function we are creating. So this function takes an argument. So you can just run the same thing that we did above, but this time, because it's having an argument, we must specify the argument. So my function, if I don't specify the argument, it's going to give us an error, right? Type error, because missing one required positional argument, right? So this is what is called a positional argument. So I've given it a positional argument that it's required, so I have to supply it there. So I can just put in Jesse. If I run it, so it's going to run it perfectly for us. Hello Jesse Pythonista, right? Very, very interesting. That is how to define a function, how to call a function. Now let's check for the type of our function. So check for the type, just go with type, then my function. Then this is going to give us the type of this, which is going to be a function, right? Very, very interesting. You can also assign a function to a variable. So let's see an example. So let's say we have a simple function like this. I can also assign that particular function. So let's go to the new func, right? New function. Then in this option, I'm assigning it to a different value, right? So in that case, I'm going with my function. So this same function here is being assigned to this new function, and I can call that same thing. So new func, then I can pass in the name. So let's say Joshua. Then it's going to print it out perfectly for us. So that is another way. Another thing you can also do with function. You can actually assign it to a variable, and it's going to inherit all the features of that function, and you can do anything with it, right? So this thing is very important to understand to help you work with decorators in the future. That is going to be Python level 0.2, right? Okay, now let's see what is behind the scene behind the function. So as I said, function is a block of code that does something. So let's understand what is behind the function, right? So we'll be using a very nice package to disassemble or find the real meaning of what is behind the scene. So let's see an example. So we'll be using this as we did earlier on. There's also bytecode package that you can also use. So import this. Then with this, you can see the various things you can do with this. So if I go with this, you can see the various methods and attributes of this. So you can get the bytecode. You can do some interesting stuff. You can use a sample. You can check the collections, do a lot of things, right? So with this, you can understand what is behind a function. Not just a function, but a variable. But mostly you get more details with a function than with a variable, right? Very interesting. So let's try it out. So we had our function above, and the same function that we have, we want to understand it. So go with this. So let's go with this option. We had this function. We had our function that takes a name like, let's say, Josh, right? So this function was the function that we had that was taking a name, hello Josh Pythonista. You want to analyze it. So to get the code, you can just go with my function, then go with that dash code, dash, right? So with this danda or underscore code, you can see the location of the function, the name of the function, and then where it is being stored, right? So this is the object, the hexadecimal, the name, the location of it, and the line, right? Very interesting. In case you also want to get the bytecode for this particular same function out of the box without using the this package, all of these things we are not using the this, we use the this later. So you can also use this same option. .co and code. So I go with this, it's going to give us the byte code. So these things are byte code, right? Binaries, right? This is the byte code for this function that we created. So this is what is going to be sent to the electrical circuit. Interpreter will work with the electrical circuit then to give us the result, right? Very interesting. That is the byte code. Now let's check for the name of the function. We realize that we had this name of the function. This is the name of the function, right? So in case I want to get the name of this particular function, I can just go with the same thing here. In this case, it's going to be my code then name. That is code name. It's going to give us the code name, which is going to be my function, right? Just as we have it above. Then in case I also want to check for the stack size, right, in memory, I also do the same thing as this option, .co.stack size. And it's also going to give us a size tag of 4, right? Very interesting. That is something very interesting. Now let's see some other stuff you can also do, right? So before we move on to these things, let's check what the disk package can give information about. So this, using the disk, then we will explain it. So let's go back with the disk to disassemble them. So now it's going to be my disk.this, and I pass in my function. I pass in this function, right? It's going to disassemble this particular function and give us all the things there. Wow. So we have a load global. So this is what is going to be sent to the assembly, right? This is assembly language, which is very difficult. So this is how it is. So what it's doing behind the scene is that it's having a global, a constant, a fast, call function, pop, return, and all of these things. So the print is a global, the constant is hello, the load fast name, all of these things. Very interesting. So with the disk you can get all of these things, right? But in case you don't want to use the disk and you want to get it straight away from your place without using the disk package, to get almost the same thing here, you can just go with the same thing we did, right? But this time it's going to be dot to get the local variables. Like this was global, right? This is local. These are the locals, right? These are constants. So in case you want to get local variables and all of these things, you can also use this one. So let's try that one for the global. This is for the non-local, which is global. Non-local means it's global. So it's going to be call names. So call name is going to print the print for us, which is exactly the same thing here. You had a print here, which is the load global. So the non-locals is the global. So which is what that's given to us here. Perfect. The same way, in case I want to get the local variables, in case there was a local variable there, I would have done the same thing here. In that case, it's going to be, instead of names, it's going to be variable names, right? In case there was a variable in my function, I would have done the same thing, var names. But this one, we had only name, right? So this name is referring to the name of the function, right? The name, not the name of the function, but the name that we supply as an argument. That is the name that is being brought here. Right, it is loaded fast here. That is the variable names, local variables. Now, in case you also want to, these are the basic stuff about it, right? So there are a lot of things you can also do. You can also check for the constants there using the same thing. So let's try that one out. You can also check for the constant, right? In case I also want to do the same thing, that is, which is going to give us this particular constant Pythonista. So in that case, it's going to be my constant variables. So in that case, this is going to be not names but const. Right, perfect. So that is how to work with understanding what is behind the scene when you call a function in Python, right? So let's face it out. So it's supposed to be const, right? Constants. Perfect. So we see that we have hello Pythonista, which is referring to the constant here. So we had load constant from here, right? We also have another load constant from here. So these are the constants that has given to us. So I hope you have understood the basic code behind any function, right? With the disk package and then with the normal understanding of it. That's something very interesting you can do. You can also define a function that has a return statement, right? So let's try that one out. So let's go def. Let's call it as, let's say, greet. me, right? Something like that. Greet me function, which takes a name. It's going to take a name. Then with the return, you're going to specify what you want to return to the user, right? So let's say I have a result here. Then let's say I'm going to take the name that the person gives to me. So the name is name.upper. I'll convert that one to uppercase, and I'll print it out, right? So in case I want to return something different, let's say we have result 1, result 2, right? So one is result upper, another one is result lower, right? So we have two, result upper, result lower. Then I want to return one of them, right? So I can just print the upper and I can return the lower. So with the return, it's going to specify which one you want to return, right? So if I go with this option, it's going to define it perfectly well, but when I run this function, it's going to only print the upper, but will return the lower. So let's see what I mean by that. So it's going to be very simple. So the same function that you have done, I can just go with, let's say, greet me, then Josh, right? I made a mistake because I typed so fast without looking. So Josh. So greet me, Josh, right? It's going to bring the Josh here. So that it printed the Josh and returned the upper, right? That is something very basic. So this is the lower. Oh, we made a mistake. No wonder it was given us the same result. So lower. You can see that I even make mistakes, right? So you will always be making mistakes. Okay, so let's run it again. If I run it now, we see that we have Josh as the printed one, and then the return one is this, right? So the return is going to tell us what we want to return. So in the same way, if I equate this one to, let's say, answer, right, and I go with greet me Paul, right? So if I go with greet me Paul, it's going to print the Paul in the uppercase, but if I check the answer here, it is only the lower that has been returned, right? So that is the basic idea behind the return statement. So the return statement is going to tell us what you want to return, right? So anytime you bring the return, no matter what you have done, what you are specifying is what is going to be returned, right? So in case I want to store it inside the value, you're going to push that particular value, return that value, and I can store it. That is why this answer give us Paul, but here inside this value called answer, we have Paul in smaller letters. That is the basic idea behind the return statement. Now let's see how to work with variable number of arguments. So you have seen how to work with one position argument. In case you have multiple arguments and you want to use them, how do you work with it? So let's create another function called by items, right? And then I'm going to pass in, this is another way of creating a function, by items. Let's make it like this. Then in case I want to supply multiple items, variable number of arguments means that I'm accepting multiple arguments, right? Even if I don't know the limit, right? So I can just go with this option, asterisk, right? Then items. It can be any stuff. So now I can print them out. So like I make it something like this. So print items, right? Very interesting. So now that is something simple, a simple function I've created. So I can supply multiple arguments there. So this is the first way. So I can do something like this. So I can just go with my by items. So I can pass in banana. If it's 1, it's going to work. I must edit all of these things, but I don't think so. Okay, so by items, banana, right? Banana. Right, so either I print 1 or 2 or 3, it's going to return a tuple of that particular value, right? So I can also do it for, let's say, multiple values. It can be banana, can supply another stuff like apple. Can also supply something like, so it can be 10, can be 20, can be 40. and it's still going to work. Right, it's going to print them perfectly fast in the format of a tuple. So with the variable number of arguments with asterisk, you can use it to define a function and collect and accept multiple arguments, right, no matter how it is. That is something very interesting about it, right? Very simple and very cool. You can also make this one better in a better format. Instead of doing it like this, in case you don't want it in a tuple, you want it in a list format, you can do it like this option. Come back and create it like item list. Then I'll just go with an asterisk, then my items. Right, so this option is going to convert everything to a list, then give us as a list here. So list is another way of doing it, right? You can use a return in case you want. Right, and you can do the same thing here. So let's copy this here, and if I run it, I'm going to convert it into a list for us. Perfect, right? Using the asterisk. So the asterisk is very, very powerful to allow us to be able to access multiple variables or multiple arguments. Now let's see how to work with keyword argument. So keyword argument means that you are attaching a value to a keyword as an argument, right? So let's see how to do that. So the simplest way is just use the asterisk Kwargs or asterisk. A single asterisk is variable number of arguments, and then multiple asterisk, two double asterisk is keyword argument. So let's see what I mean by that. I'll be creating a simple function with a keyword argument and a default parameter, right? So let's see how to do that. So let's call this triangle. And we already know that triangles have a base and then a height. So this is a simple function we have created, right? But in case I want to create a keyword argument with a default value, then I can just put the value there 0, right? And then let's say this one is going to be, let's say 20, right? So this is going to be the default value. Now let's create our result, which is 1/2 times base times height, right? I hope you remember the formula for triangle. Then now I can return it. So return result. So that's this simple, right? So we have defined a simple function that takes a keyword argument with the default stuff. So in case I want to get the default values, right? If I go straight away with triangle, because this is not just a keyword argument but also positional, if I go straight away with 20, right, and I leave it like that, it's going to automatically use the height, right? Automatically going to use the height, the default value, and give me the result, right? So this is in a positional way with the default. Very interesting, right? So to identify that this 20 is referring to the base, then by default is to use the height as a default value. So in the same way, I can also specify, let's say I want to change the height to, let's say 30. So going to work perfectly for us. So these things are positions. I can't change it, right? So they are specific. But with the keyword argument like this, now I can change it irrespectively. So now I can do something like this. Right, there's a triangle. Now I can bring the height first, then put, let's say 40 there, and then the base I can put, let's say 10, and still going to work irrespective of the position. So that is the advantage of using the keyword argument. It gives you the option of using the same parameters but in a different format, and it's still going to work perfectly. Now let's see how to work with multiple keywords. In case you have multiple keywords and don't want to write all of them, like triangle, height, base, all of these things, how do I do that? So you can use the keyword argument. So in that case, it's going to be very simple. So let's call something like, let's say make emails, right? So in make emails, I need my first name, last name, and some stuff. So in that case, I can just go with asterisk, then I can just supply names. So this thing can be anything, right? But the most important thing that it must have asterisk here. So you just go with this option. Then now I can create my email. So let's call this email. It's going to be let's join them together. We can join them together, or we can, let's join them together. So I'll be joining with this robot dot join, then I'll pass in my names, right? If I pass in my name, so this is going to return it as a format of a dictionary, right? So let's first of all make the simple one first. So let's go to as result, going to, or let's print it. So this, the keyword argument is going to return it as a format of a dictionary, right? And then the variable number of arguments is going to return it as a format of a tuple. That is something you have to understand about it. So this is going to be among the last video we're doing. I've taken a lot of time. So let's see how it is going to be something like this. If I make emails, and I supply a single name, like let's say coffee, right? It's going to print it out perfectly for us. So we make emails to coffee. So see that it's giving us an error, right? So the reason it's giving us an error is that this is a keyword argument. So it needs a keyword, right? So I have to supply the name. So in this case, it's going to work perfectly. Perfect. So that it gives us in the format of a dictionary. So Kwargs, right, always comes as a dictionary, but Vargs, right, variable argument, comes as a tuple. That's something you have to understand about it. To give us as a dictionary, I can also do the same thing and add another one to it. So let's add something like the age. Then have you noticed that I'm always making a mistake with the comma, right? So if I go with, let's say, age, then I can pass in age as 24, right? If I run it now, it's going to print it as a dictionary for us, right? So that is how to work with keyword argument. Very, very interesting and very, very powerful, right? It always comes as a dictionary, right? That is so nice and so cool, and you can actually use it to do whatever you want to do. But the most recommended way of working with keyword argument is that instead of using names like this, you can use the accepted format, right? The convention, by going with this option of the same thing, right? It's still going to work, but instead of using names here, just go with the Kwargs, so that if somebody is reading your code in the future, the person will know that this is Kwargs, right? Something like that. The Kwargs. It's still going to work perfectly for us. So since it's a dictionary, we can do a lot of things with it. Very interesting. And it's still going to work as above, right? So all of them are going to work perfectly. So if I run it again, so I can give it as many as I wish, and it's still going to work. Now let's do a simple analysis, a simple disassembly of this particular function. Let's see what is behind it. If I go with this dot this, let's pass in my make emails. Let's see how it is. Wow, so this is something very simple, right? So load global as we have known it. That's something very basic about functions. Now let's move on to documenting our function. So how do you document your function? So in documenting our functions, it's very important to document your function. You can use docstrings to help us, and then with this option of documenting your functions, when you are building a package or a model, it can be used to generate documentations for you automatically. So let's see how to create a simple function, and let's see how to get the document from it. So let's create a function like, let's say, thank you, right, for watching. You have stayed with me. Then the person's name, right? So how do I create a documentation for this? So to create a documentation, just come back and create a docstring with the triple quotes. So this is a docstring, and I can pass in thank you from docstring, right? Something like that. So this is the documentation that's going to be used, right, for that, in case I want to get something about it. And I can, let's say, I can print f name using the f string. So let's make it like this. Thank you. Then I'll pass in the name there, which is going to be the name, right? So something simple, something very basic. So let's make it like this option. I hope you can see it. So that is something simple, right? This is a simple function. So we have created a simple function that does something. So if I come back here and I run this function of thank you, I pass in thank you everyone. If I run this thank you everyone function, thank you everyone, it's going to work perfectly. But in case I want to get the documentation for this particular function, what does this function do? The first method is to use the help. So I can just go with this help function and I pass in my thank you function. So I pass in my thank you function, which I defined. So to be thank you. Then go to print the thanks for docstrings, right? So help on function thank you, then thank you, then thanks from docstring. This is this same thing here. Okay, this is the first method. The second method is to use this option of the function that we had. So thank you, not thanks you, thank you. Then I just go with dot underscore doc underscore or danda, right? It's also going to do the same thing and print it out. Thank you from docstring. So these are the two methods for getting help, right? Anywhere in your function. But in case you are working inside Jupyter Notebook or IPython, you can just go with the question mark, right? And you pass in your function, which is going to be thank you. So going to bring it up perfectly for us. So this is the signature thank you from docstrings, the file and the type. That is something very interesting about functions. So you have learned a lot today. Thank you very much for learning, for staying with me. I hope you have learned a lot. Now let's conclude with the file IO, file input and output, right? So we can open a file, write a file, read a file, and do some things. So you have already seen how to output something. Now how do we receive something? So you have seen that to output something, you use the print, but to input something, to receive something, you can use the input or the raw input in case you are working from Python 2.7, which has been deprecated by now. So let's see an example. So in case I want to print something out, so say print hello, we output it, right? That is how to output something. Perfect. In case I also want to receive something, to receive from the user, like maybe you create a program, then you want to receive from the user, how do you do that? So it's going to be very simple. So in that case, it's going to be something like this. So it is simple like this. So it's going to say I'll pass in the name, right, of the person that I want. So let's make it like L name for the last name. Then in case I want to receive from the user, I just go with input. Then I'll pass in, so enter your last name, right? So if I go with this option, I can just run it, this one here, right? Then let's bring the print L name here. So now if I run this simple stuff, it's going to give me the option of giving a bar, right, an empty space in which I can put the name there. So let's name is JCharis, right? If I click on enter, it's going to print it out perfectly for us. So that is how to receive input from the user. It's very, very useful in case you are writing a script. Very nice. So now let's see the next option of how to open a file or create a file, right? So to create a file, it is very simple. You can create a file from Python. You can also create a file from somewhere and then read it, right? So how do we do that? So the simplest way is just go with create a variable. So let's go to variable 1, file 1. Then I'll just go with open. Then with the open, I can do some stuff. So I can, let's say I want to open a file called example file, right? So I'm opening a particular file. I've not created it, but I can open it as a TXT file. Then in case I want to create that particular file or write to it, I just go with W. So the W here, I'm still making the same mistake. W here means write, right? So we can have, it can be in this particular format. It can be W, can be WB, can be W plus, right? Can be R, can be RB, can be R plus, can be A plus, right? So the W and then WB, W plus means that write byte, write and append, right? Then read byte, read and append, like that is the basic idea behind this. These are the basic modes. So it's going to be in this particular format, the file name and then the particular mode that you want. So let's create a file by going with WB for read byte. That is the basic stuff, right? So if I run this now, it's going to create the file example.txt file. So if I come back and I check it from here, you can see that you have our example.txt file inside our file here. Perfect. So now let's see how to write something to it. So to write to it, I just go with file 2 or file 1, right? Dot write. Then I'll write it. Since I went with write byte, I have to specify a byte format with a B. Then I'll pass in my stuff. So let's say if I go with this option, right, let's pass in something like, let's say writing to test. It will give us an error because the file is in a byte format, right? So I have to convert it to byte. So the simplest way, just go with B, right? The B there is going to tell you that it's supposed to be in a byte format. It's going to write it without giving us any error, right? Perfect. So this is the byte, the 15. Now, in case I want to open it, I have to first of all close it first. So file 1 dot close before I can read it in the future, right? That's the basic idea behind it. That is how to work with writing, opening a file, creating a file, and writing to it. This is one of the methods, but the best method is to use the with open, right? Which is always the best method. So let's try that one out. So the best method is the with open. So it's going to be with, right? Then open, so that I don't keep on opening and closing, doing all of these things. With the with open, it will automatically close it after you are done, right? So with open, for example, file.txt. And since we are reading it, we can just go with read byte, right? It can be read, then as f. So I'm opening this particular file and storing inside this particular file f, just like we open it and we store inside a variable called file 1. Here we are storing inside a variable called f, right? It can be any file, any variable. Then I'm just going to go with, let's say, data. I want to read it, so it's going to be f.read. So it's going to open the file and read it for us. That is the simplest stuff. Then I can print it out. So this is supposed to be data, not, see how I spelled it. Perfect. So that is the basic idea behind working with it. I hope you have learned something. So now if I run it, it's going to print it out perfectly for us. Writing to test. That's the basic idea about how to work with Python, right? So all that you have done so far is about the basics of Python. So in the future, we learn about how to read other file formats. So there are packages that allows us to read JSON file, CSV file, PDF, YAML, and several other file formats. That is the basic idea about Python. Hope you have learned something. So before we move, let's see how to create a file from somewhere. All that we did was in Jupyter Notebook, but be creating a file and then run something that you have done. So let's go back to our terminal here, right? And let's try an example, right? So let's create a file. So let's call it, let's say, my script.py. Perfect, right? So this is how to create a file, right? So it must always have this extension of py for Python, right? So let's open it with Sublime Test. One of the things that we used when we started the course, one of the tests that you can use VS Code, you can use Sublime. Perfect. So this is Sublime Test, right? So we created a file, and the file was called my script.py. So let's see another way you can create it. So go to your text editor, go to file, create it as new file, right? Then you can save it. So let's go and save it, but in saving it, you should make sure that the extension is .py, right? So .py means that .python, so that it will be able to understand it. It's taking some time for it to open. So this is it, right? The same thing. So in case I want to call it, let's call it as, let's say, my program.py, right? So the extension must be .py. Very interesting. So either you use the terminal to create it, or you use the text editor to create it. So to work with Python, that is something very basic. Now, this most recommended way is that all that we did, we can write inside a file, right? So all that we did, we can also write it inside a file like this, right? Very interesting. So I can just write something very simple. So def hello. Hope you can see it well. The same thing that we did. Now passing the name here, and now I can just print the name, right? Something like that. Very interesting. So now in case I want to actually execute it, I have to call it. So let's call it as hello. Then I'll pass in everyone. Very interesting. So to run this particular file, all I have to do is I just go back to my terminal, right? And I'll just go with Python, particular Python version that you're using, Python, right? Then you supply the file, which is my program. So with this option, it's going to run the particular file, everyone, right? Very interesting. Let's make it nicer. So print. Right, so let's save it, and now let's run it again. So if I run it, let's bring it down so that we see what you have done. Hello everyone, very interesting, right? So that is how to work with it. Very simple. The reason it's given us this option is this is Python 2.7. with Python 3.6 I have two different Python versions. Hello everyone, right? So that is how to run a script inside your terminal. Very interesting, right? Very nice. For you to not be defining Python 3, Python 2, there's a simplest way by coming back to the top of a file and use the shebang, right? It's called shebang. So shebang, right? Shebang. Shebang. So a simple example of this is going to be this. Then bin slash, right? So shebang, then bin. That is in case you are in Python or any other stuff. So it can be this option, right? Or you can just go with this user bin, right? Then you supply the particular stuff. So let's go with Python. If I go with Python now, right, it's going to use Python 2.7 to work on it. So if I save it, this is very important. So the hashtag exclamation user bin Python, something very simple. That is one of the ways of doing it. You can use this option, and let's run it and see. If I come back here now, for me to run, I can run it like this. It's going to work, right? But in case I don't want to run it like that, I can just do it cmode plus, then I'll pass in my program, and because of this keymode plus, I've given it right privileges, so I can just go straight away with this. My program is going to run perfectly, right, without calling Python, right? So that is the basic idea. So because of the shebang, it's very interesting. Automatically going to use Python 2.7, but can you use Python 3? Change this one, the same thing here as we did, and this is for Python 2.7. But in case I want to use Python 3, I'll just change it here. Then I'll do the same thing I did. Give it right privileges, and now let's run it. Perfect, right? So to automatically use Python 3 to do that. That is something interesting about writing programs and working with Python. There's, of course, there are several things you can do with it, but these are the basic stuff about it. So I hope you have learned a lot. So thank you for watching this long tutorial. Hope you have learned a lot. So in the future, I'll be learning about some other ways, other stuff, and how to apply all that you have learned to do some interesting stuff. So thank you for watching. So thank you for watching this long tutorial. Hope you have learned a lot. In case you need help, you can contact me in the comment section below. Now there's one last thing to do. So in case you want to convert everything to a Python file like this, right, that we did, there's a simple way of doing it in Jupyter Lab, which is just come back to the file, then just go straight to export as. Then you can export as PDF, as Markdown, as restricted text, or as executable script. If I go with this, so to convert everything to a .py file, which I can use to do whatever I want to do. So that is something very basic. So let's see how to do that. Perfect. See that I just finished converting everything here. You can see it in the format of .py, right? So you see that is telling us that it can be harmful, right? Because it's an executable script, but I can just keep it, right? That is something very basic, something very simple. So thank you for watching this tutorial. In case you have any questions, you can just check the comment section below, and everything will be inside on the website and on GitHub. Thank you and stay blessed. Bye. Thank you very much.